stream is starting. The Captain Coder at the helm. Bean water is ready. Today we will learn a lot. He loves the questions, he loves to sing. Join our Discord and follow him.
Good morning, good afternoon, good evening to you, wherever you happen to be in the world. Captain Coder here on this beautiful Sunday, and we already got Tom in Pixels. Tom in Pixels, I'm in love with you, and I'd like to say welcome aboard. Thank you for following me. Tom in Pixels, what a cool name. What a cool name, Tom in Pixels. Thank you so much for the follow. Happy Sunday, my friend. I hope you're having a beautiful day wherever you happen to be in the world. We've got the whole crew here today. I'm so excited to be here. We got everybody. We're here for the Advent of Code, people. The Advent of Code. I'm so excited to have you here. Clayman, thank you so much for the first. Draco, sorry you got robbed there by Clayman. Clayman came in, scooped up that first. Dramel, I'm also glad you're here with us, my friend. I hope things are going well. Binary G. Have you met Binary G? They are following me, and I would like to say thank you, Binary G. If you're a Binary G, so you got a G and you have a G nut and a G and a G nut. Is that how that works? Are you a Binary G? I love it. I love it. Great name. Welcome to the stream, my friend. Happy to have you here on this beautiful Sunday. Good morning from me to you. Good afternoon, good evening, wherever you happen to be in the world. I hope you're having a beautiful day. We also got the one, the only Corfless here. Corfless, folks, you guys don't know Corfless. Incredible human being, incredible person, incredible supporter of the stream. He's been here almost the entire time. Human being, does gaming, does programming, sometimes on stream, sometimes not. Currently, he's trying to finish his degree as a computer scientist, while also being a psychology enthusiast. He's a part-time teacher coding with kids as well. I'm a 011001111. Nice. I'm assuming that's the ASCII G. The ASCII G, got a capital, got the lowercase. That makes sense. That makes sense. I'm so glad you're here, my friend. Balint, welcome back to the stream as well. And G, I'm so glad you're here with us. G, always incredible to have you here with us. G, killing it on the leaderboard, I believe, too. Let's check out our private leaderboard. Folks, we are working on the Advent of Code. What's the leaderboard show here? G, just destroying it. G's finished all the stars so far. So G has completed today's task. So it's possible. It's possible to finish it. There are 2 G's now, not just one. Clayman, this is your house. Is that the North Pole? He's Santa Claus. Is that the North Pole? If you have all zeros, 0 north, 0 east. Oh man, that bean water is good. We also got tuna omelet. You make me feel so hungry. You make me want to have breakfast. And put some tuna in that, eggs, mix it up, whisk it up. Oh, it's gonna be so good. It's gonna be so good. What are we doing today, folks? What are we doing today? I'm so excited to be here. I'm tired. I'm tired, folks. I'm tired. That's my excuse. You heard it here first. I'm tired. So if I can't do it, it's because I don't have enough sleep. That's just because I don't have enough sleep. What are we working on though? What? We are doing day 10 of the Advent of Code, which is Pipe Maze. Pipe Maze, day 10 of the Advent of Code, Pipe Maze. If you're not sure what Advent of Code is, you can check it out here. Advent of Code is a coding puzzle gift brought to us by Eric Wastel. Incredible programmer, incredible human being, creating these puzzles for us every day in December. Not every day, the first 25 days in December, we get not only one puzzle, but we get 2 puzzles. We get 2 puzzles every day in December. But you have to complete one to get the next. It's pretty cool. Pretty cool. If you like programming, if you like puzzles, if you want to learn something new, maybe these are a great way to do it. Let's look at day 10 here. We've done days 1 through 9 so far. This one's called Pipe Maze, so I don't know what we're doing, but I'm just gonna assume. Maybe I shouldn't assume anything. I was telling people yesterday was such an easy puzzle. Today's gonna, they're gonna get us. They're gonna amp it up here, crank it up to 10, crank it up to 11. Binary says, to be fair, my name is usually shortened to BG, so we good. Gotcha, because we got G, 1, 2, 3, 4, 5, and then the binary G. That's right. It's time to fight. Get some of that bean water in my mouth. Get that bean water in my mouth. It's delicious. Here we go. Let's read this puzzle. Let's hop in. I forgot to set up my VS Code again. All right. Let's read this. Look, I'm not a good streamer. I forget too easily, folks. We're gonna go ahead and zoom. Bean water is the best. You know it. Yeah. We know it. You use the hang glider to ride the hot air from Desert Island all the way up to the floating metal island. This island is surprisingly cold and there definitely aren't any thermals to glide on. So you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they are the same metallic silver color as the ground. You make a quick sketch of all of the surfaces around, surface pipes you can see. My brain was jumping to some conclusions there. The pipes are arranged in a two-dimensional grid of tiles. We got vertical pipes, horizontal pipes, we got L's, we got L bends, we got Tetris tile, we got L's, we got J bends, we got 7s, we got F's connecting southeast. Okay, so these are the corner pipes, dot is the ground, S is the starting position of the animal. There's a pipe on this tile, but your sketch doesn't show what the shape the pipe has. If the puzzle is literally just, can you infer the shape of S? That would be probably the best hope we have right here. Oh, that's good. Based on the acoustics of the animal's scurrying, you are confident the pipe that contains the animal is one large continuous loop. For example, here is a square loop of pipe. I like that they're using F's and 7s and J's and L's to represent the corners. There's no T pipes. There's no T pipes. There's no plus pipes. So maybe that's a good thing. Maybe that's a simplification. The animal had entered this loop in the northwest corner. The sketch would instead look like this. Okay. So then we have the pipe loop. In the above diagram, the S tile is still a 90-degree F bend. You can tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loops. This sketch shows the same loop as above. Okay. So we've got a bunch of extraneous pipes as well because whoever constructed this set of pipes was a fool. They just, when they were done, they're like, all right, just scatter the rest of the pipes around. We've got Squidarn. Welcome to the stream. Squidarn. Oh, Squidarn. Thank you for following me today. We've got Squidarn. Oh, Squidarn. Welcome to the family. You know you have followed me, and I'd like to say thank you so much and enjoy your stay at Captain Coda's Academy. Welcome to the stream, Squidarn. Happy to have you here on this beautiful day. All right, let's keep reading this post here. Thank you so much for the follow. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S pipes. S pipes those connect, pipes those pipes connect to, pipes those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connecting to it, and which is assumed to connect back to those two pipes. So every pipe, because it's a loop, every pipe has exactly two pipes it's connected to, okay? Here's a sketch that contains a slightly more complex main loop. S loops around like this. All right, so we're gonna have to do. Well, let me read the puzzle here. I'm already jumping to conclusions. Here's the same sketch with the extra non-main loop pipe tiles, also shown. All right, so they've added in. J goes over and down. So they've added in stuff like this to distract us. If you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. In the first example with the square loop, we have this. You can count the distance each tile in the loop is from the starting point like this. This looks like breadth first search. Is there anything else we can do? Is it always going to be breadth first search? Depth first search won't look because we actually don't know where the end is. We're trying to identify the end. So we need to go through and build up a breadth first search. I guess depth first search would work if you did if you marked the tile position correctly. So depth first search, is that right? No. If you kept your stack size. No. We're gonna do breadth first search. I'm not even gonna try depth first search. I'm pretty sure breadth first search is the way to go here. In this example, the farthest point is 4 steps away. Here's the more complex loop again. All right, so we have that. Here are the distances for each tile on that loop. Find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? All right, so breadth first search isn't too bad to implement. The hardest part here is probably gonna be parsing this into a graph. Parsing it into a graph. What do I think here? And then performing the breadth first search on it. Excuse me. Give me just a second here. All right, we're back. We're back. Let's take a sip of this water here. Okay, so we need to parse our grid. And how big is our puzzle? It's pretty big. Pretty big puzzle. Okay, we're gonna try and do a breadth first search on this. So let's get my project set up. Let's get my VS Code project set up. We can do this. We can do this. We have the technology, folks. We have the technology. Let's come up, make 10. It's a lovely little maze. Yeah, so we're gonna have to do build the maze, find the S, propagate out using breadth first search. Let's get our project.net, new SLN. It's amazing. That's right. Implementation, make their tests. CD test. Let's go to my implementation first. CD implementations. Let's make a new console project. So good. .NET SLN add our implementation. This is one that would be my. We're gonna do it first before I start talking about doing extras. Do it first. .NET new XUnit. So we're adding an XUnit test. .NET add reference. It's gonna reference our implementation. Let's add Shoodly.net add package Shoodly. I'm getting close, and I know the version needs to be version 4.20. Is that right? Shoodly Nougat. I should start to 4.2.1 -- version 4.2.1. There we go. Come on. Add package. No S, just one package is being added, folks. We're gonna add this in here. And then we're gonna do a .NET add SLN or SLN add our tests. And then we're gonna open this bad boy up. Let's open it up, folks. All right, so here we are. We have our project here in the versus code. Let's get this base project committed. Let's make sure this makes sense. Git commit -m chore initialize projects for day 6, day 10. Push that up there. Phil Barracks, follow up, rating me. We've got Phil Barracks, rating me. Phil Barracks rated me. Phil Barracks, thank you so much for the raid. Good morning, good afternoon, good evening to you. Happy Sunday, my friend. Thank you so much for the raid. Folks, if you guys don't know Phil Barracks, you should be checking Phil Barracks out. Let's give a shout out to Phil Barracks, folks. Folks, you want to watch a game developer, a programmer, an incredible human being. You see this heart right here? This is your captain speaking to you. Your captain wants you to click that heart. Give Phil Barracks all the love you can give. Phil, how was your stream? If you got a raid and run, let me no problem. But I want to say welcome to the stream, my friend. Happy to have you here on this beautiful day. We've got Keen on Twitch following us. Keen on Twitch. Thank you for the follow on this beautiful Sunday. Thank you so much for the follow, Keen on Twitch. And then Phil Barracks, thank you so much for the follow. Have you met Phil Barracks? He has followed me today. You know, Phil Barracks, man, I love you. Thank you for the follow. Thank you so much for the follow. I appreciate you, my friend. Welcome to the stream. I'm doing absolutely wonderful. We're just popping in here. We are working on the Advent of Code. We are doing the Advent of Code, AOC. If you're not familiar with Advent of Code, it's a series of puzzles that gets released in December by the incredible Eric Wassel. It's so nice to have you guys here. Ghost Lupo, thank you so much for being here. Thank you for coming in on the Raven. Hyperion's Live. It's nice to have you with us, my friend. Also, Nijad Coder, welcome back to the stream. What were you working on, Phil Barracks? Let me give you a permit. One sec. Permit. Phil Barracks. If you got any links to things you're working on, feel free to drop them in the chat. Feel free to share what you've been working on. But thank you again so much for the raid. I'm glad you're here, my friend. All right, folks. I completed a general hacking skills CTF. What does CTF stand for? My brain can't handle it right now. Need job cutter. General hacking skills certification. Congratulations. Nice work. For those of you just coming in, I am Captain Coder. Captain the Coder is me, and me is a computer science educator. I teach computer science and programming. That's my full-time job. I'm in school for ages 10 to 14, working on Stream Slugger. Nice. All right. So we just created a project here. I was wrong about it being certificate. CTF is like a puzzle. So is it kind of like hack the box type thing, or like hack this site? Phil Barrett says it's a stream overlay. Is a stream overlay game? It's a game that people get to play. All right, we're gonna write a unit test here. Unit test. We're gonna call this day 10 tests. Okay, and we'll rename this file here. Working on it. Gotcha. How long have you been working on it? You completed the entire category of general skills on Hack the Box. Nice work, Job Coder. I should do some more of that. One of my favorite, there's one what is it? Overgrown Carrot 21, I think, is incredible as well. You've been working on it for 8 months. That's a long time. It's a long time. How are you getting close to release, or is it already released, but you have like you're making improvements upon it, Phil? All right, we're gonna test sample input part 1 here, and over here we're gonna create a new file, day 10, public class day 10. Nope. Autocomplete. Calm down. Need you just on Pico CTF. I mean, it's like the heck the box for saying it wrong. No worries. It is released and making more features. It's on Steam. Yeah, if you want to drop a link to it from Steam, go ahead. We'd love to check it out. Public static long. Thank you for the link. I'm gonna open up that in just a moment here. I'm getting my puzzle input set up here just so I have my test. Go away, you. Let's pull this up here. We have our input should be 8 here. How many steps long loop does it take to start and finish the furthest distance? Here's the distance for each time that loop. Here's a more complex loop. So this is one of the inputs. Public static, nope. Public static string sample inputs equals triple. Give it the old triple. Nope. Give it the old trimmel. Tim. Give it the Tim. Now we're gonna trim it. Boom. So we got that sample input. This would be day part one string input, and for now we're gonna return a 0. But we're gonna write a little test here using shouldly, and we're gonna go day 10.part1 of sample input dot should be 8. All right, so at least we'll hopefully get that. All right, Phil, enjoy your lunch. Welcome to Lurk Mode. We appreciate you lurking here with a lurk here and a lurk there. Here a lurk, there a lurk, everywhere a lurk. Folks, be sure to go check out Phil's Stream Slugger. Stream Slugger, it creates an additional content on your screen, live stream, and video. 3D Character keeps your company while working, having fun. Awesome. Need job cover. I love that you love the streams. I love having you around, my friend. It's so nice. We're gonna check this demo out at some point. This looks cool. Connected or not to your Twitch, you and your friends can have engagement in your stream, and even contribute to your channel growth. Very cool. Grim's Deep, welcome to the stream. I'm happy to have you here, my friend. Yeah, I use VS Code for C#. If you're on Windows, I always kind of recommend use Visual Studio instead of Visual Studio Code, 2 different programs. But the school I teach at, we use Visual Studio Code because we have lots of programming classes, and it makes more sense for us to teach just one tool. But Grim Desk, sorry, not Grim's Deep, I got that totally wrong. Grim DESP, Grim Desk, welcome to the stream, my friend. Happy to have you here. All right, let's make sure this builds.net, build it up so you can tear it down. All right, it builds. Let's load these tests in. Let's make sure we're failing. Come on, fail. Come on, try again. I don't know why the left one doesn't work. It's weird. It lets me click that. All right, we failed. That's good. Okay. We have one very simple test here. We need to parse. Okay. We need to build up a graph of pipes. Maybe I can just read this in here. Let me think. We have three types of pipes. All right, I'm gonna do. I'm gonna use a dictionary. To handle my input. I could do. I like dictionaries just because it's so easy to handle the edge cases of whether or not something's gained in. So for my purposes, I'm gonna go ahead and I'm gonna loop through this input, row and column. So we're gonna take our inputs. All right, we need to write a parser. Let me create a public, we're gonna create a data structure here to hold our maze. Public, class, maybe I should make it a record. Public, class, maze, like this. And our maze is a dictionary. Public, let's make it private, I suppose. Dictionary. Rows and columns, I like to do this way. So public, record, position, int row, int column. So this is going to be a row and column in our maze. And then our maze is going to be a dictionary of position to pipe. Okay. And it's going to be our pipes. Like this. I'm going to make this a private read-only dictionary. And when we construct the maze, I'm going to do it via a parse method, string input, like this. So this is going to construct a maze. I need a maze type, a public enum pipe. There's going to be none, so this means that this is going to be equivalent to the dot. So we have a dot. Let me look here, just double check. We have, these are our different pipes, yeah. S is our starting position. So there's a none. I guess technically we have starting. I don't necessarily like that. None, let's call this ground. Ground. So we have a ground, we have a starting, this is our S. Like this. Someone did this really, Steve. We can make this a U short here. Was showing me this really cool thing. We can actually say ground is equal to a dot. Oh, I love that. It's equal to an S. If I did this as an int, I could do it as an int anyway. All right, never mind. Never mind. I don't need to care about that. Okay. These are different ones. I'm gonna copy this in so I have it up here. Like so. Oops, didn't mean to lose my record. Should really put this in a common place because I have a bunch of positions. I use position frequently enough. All right, so we have our starting. We need vertical. We need a horizontal. Have moon. Welcome back. I'm doing absolutely wonderful, my friend. I'm doing absolutely wonderful. Any day I can wake up and code is a beautiful day, and today is no different. Today is no different. If I do this and do a format, I bet it's gonna break it. Yeah, so I'm just gonna leave it. Smab, welcome to the stream, my friend. We just started part 1. We're gonna parse it in here. I'm probably doing overkill as per usual. We're gonna do a breadth first search on this input. We're gonna find our S, and then we're gonna do a breadth first search over it to solve our maze, it's not really a solving a maze. We're gonna do a breadth first search over it to discover our distance. I guess it's technically solving. You don't know where the end is. You're actually discovering the end in this puzzle, which is really interesting. Compared to like a traditional maze, it's like here's the start and here's the end. We need to figure out the shortest path. This one you have the whole loop and you're just trying to figure it out. So we haven't parsed it in yet, but we're gonna go ahead and do that here momentarily. I'm setting up my data structures, and I could probably use the grid directly, but this is just how my brain likes to do things. This is my brain wanting to over-engineer things, and that's fine. That's fine. We're gonna call this a bottom left. Is gonna be an L here. Because that's right, so that'd be the bottom left because we're making an L shape, and my camera is showing in reverse from what I'm doing, but we're gonna do an L shape here. So I'm calling that bottom left. It's a corner. Bottom right is gonna be a J, and maybe I should call it just like an L joint, a J joint, top right is gonna be our 7, and top left is gonna be our F. Then do I have them all now? Dot, then 1, 2, 3, 4, 5. So there's 6 different types of pipes, and then we have a ground and a starting position. Yeah, I you know, honestly, I don't know that I actually need all of these when I'm parsing it in. I really only care about my pipe joints. I really only care about the pipe joints themselves. And then S, we have to like infer what S is. So I might end up not using this. We might just have a position to pipe, and then I can ignore the ground itself, actually. I think I might try that. You know what? I'm gonna try it. I think I can get rid. I don't need to even care about the ground and the starting if I'm doing it as a dictionary from position to pipes, and then we sort of can ignore it because we're guaranteed that the loop, it loops around and creates a loop. It specifically says that in their input. So yeah, so that's what we're gonna do here. I'm really curious if I can do some casting now from this to our pipes here. We're gonna find out. Yeah, but we have a position which has a pipe, and we're gonna have a thing that like tells us what are the neighbors. Given a position, what are the neighbors that we can travel to, and we're gonna do a breadth first search. We're gonna do a breadth first search. But Smab, how the heck are you doing today? How did you fare? We looked at the leaderboard momentarily, and I think I saw that you had finished this one. We were looking at it just a hair earlier, and it looked like you had finished. Yeah, Smab's got it. G's got it. And anonymous user number 3325057 has got, oh, quite a few people. Hepe Leo's done it. This one's outside your comfort zone. Gotcha. I haven't gotten to part 2. I'm kind of assuming they're gonna do something crazy, like find all the it turns out the animal was a ghost and can travel through hyperspace. Yeah, so we'll find out. It's a bit different than the previous 9. Yeah, I know you don't like the pathfinding ones all that much. You don't find them interesting. Part 1 is just a breadth first search, I'm pretty sure. So we're gonna do a input.split on new line, and then we'll trim those entries. So this will give us our rows. So this is string array rows, like this, and we're gonna loop through it here. I learned a lot and tried 3 different methods, which were all partially successful until I had an epiphany. G says, I like these 2D puzzles, but I don't like 1D and 3D puzzles. Gotcha. The cube one last year was super cool. That one warped my brain a little bit. Oh, excuse me. I tried to mute, but I didn't. The cube one warped my brain a little bit last time. Excuse me. So we're gonna do 4 int row equals 0, row is less than rows dot length, rows plus plus. So we're gonna loop through that. Caveman crafting, welcome back to the stream, and I would like to say thank you for following. Thank you for the follow, Caveman Crafting. It's going wonderfully well so far. We're parsing some stuff. We're having some fun parsing. And column gonna be less than rows of row dot length all plus plus. So we're gonna loop through all the rows and columns of our inputs. We're gonna pull things out. But Caveman Crafting, how the heck are you doing? Smap says, I'm going to go back and try some of the methods where I could only get some of the test paths. Gotcha. See, making me nervous. And we're gonna build up a dictionary of our pipes like this. Pipes. There's a new dictionary of pipes here. Oh, what did I do? Here? I'm about to start working on a state machine system for my preschool teacher AI game I'm building. That sounds really cool. Caveman Crafting, do you teach preschool or you got hired? Tell me more about this. This sounds awesome. A preschool teacher AI game I'm building. Did you know I went to college? I went to graduate school to study computer science education, and I'd be really curious what you're building there. I studied something called intelligent tutoring systems. Intelligent tutoring systems was one of the things I studied, and I'd be really interested to know more about your preschool teacher AI game, what it is. Sweetgrass says, I didn't even know what to Google. Gotcha. We're gonna see what happens when we get to the next part. What did I do here? Are these real errors? I have a daughter and I tossed together some sort of little app. Gotcha. Where she could talk to a chatbot via voice. I am so curious how we can utilize GPT and these new LLMs. What did I do wrong here? Let's return null for now. Return null. And so expanding on that, I have to work more as a teacher. Gotcha. Oh, I have private read. I have this crazy thing here. There we go. I'm gonna return null at the end. So, sweet radish. Sometimes that happens. Sometimes you're just like, I have no idea what to do, and I'm just gonna step away. And look at a solution. That you can learn a lot by doing that. So what I would say is look at the solutions. Maybe not look at an actual coded solution, and then think about what they've done there, and see if you can produce it. ChatGPT. I'm now using an open source LM via GPT-4All. Very cool. I need to do a little bit more with that stuff. We have a class at the school I teach at that does a little bit of prompt engineering and stuff like that. I'm gonna create a private, maybe I can make this public, maze constructor. Maybe really I should just make this a record, public record, dictionary, I'll make, dictionary position, pipes. Poops, I almost typed poops. All right, we'll just make this have a dictionary of pipes there. Can I make it an I read only dictionary? There we go. I read only dictionary. There we go. So no one can change me once I'm constructed. Either of my current solutions are pretty, I'm sorry to hear that, Smab. Sorry to hear that. We're gonna find out how my solution goes here. You don't have a pretty solution for part 1 either? Or are you saying for part 2? I feel like part 1 is a straightforward, so now I'm nervous. I feel like it's a pretty straightforward solution here. All right, so for part 2, okay. For part 2, I need to take a character, so char ch at rows, row column. All right, I'm gonna change this from rows here to maze at row and column, because the word rows there is throwing me off. Maze at row and column, and I want to try something. I don't know if this actually will work. I'm gonna say if ch is one of these letters, then we're gonna do a mapping to, I kind of want to do, can I cast ch pipe b equals ch pipe? Can I do this? Okay, this is what I was wondering if I can do. If I could do some creative. So some of my own code I wrote last month for this. Gotcha. People with computer programming would have already known part 2. I don't know. Smab is one of the best computer programmers I'm aware of. Competitive. Sorry, competitive. Gotcha. We'll see what I think of part 2. All right, so we're gonna do a pipe here like this, and really we just want to make sure it's one of these. I could also just discard. Hang on, I'm gonna do if ch is not in. Can I do an in? We're gonna do a valid. My brain can't handle it. Hash set of pipe valid. Valid is gonna be a new, and these are the valid pipe. Vertical pipe dot vertical, pipe dot horizontal, pipe dot bottom left. I'm gonna put this up here too. Can I put this in here? Can you? Oh no, I can't. Enums aren't classes here. Why can't I do this new patch set? A pipe? Can I not do this? I can do this. I can do this. Hang on. Hang on. I can do this. I can't do this. I thought I'd be able to do this. Come back in time. Hang on. Hang on. I'm bad at life. We got this. Here we go. All right. These are our valid pipes. I'm gonna have to clean this up. I'm really disliking it so far. Competitive. Yeah, definitely. Most of these people who are good at these competitive things aren't gonna break a sweat until much later. Okay, so these are our valid pipes. And what I'm gonna do here is I'm gonna convert this to a pipe. We're gonna say, if our valid dot contains ch, and we're actually gonna call this pipe. If it doesn't contain the pipe, we just continue. We just go to the next thing. Otherwise, we have pipes of row column pipe like this, and it wants me equals pipe. And I have to make this a position, new position. Okay. So this should parse out my whole maze into this dictionary here. And then we'll do new maze of pipes like that. All right. So it'll build that, and technically 2 read only, 2 frozen dictionary. That's not what I want. I can technically pass this in here, but it will, we'll do new I read only dictionary of pipe. This is the, oh, it doesn't have that. Oh, sorry, this is new read only dictionary. What are the subclasses of read only, or do I have to import that? How do I construct a read only? What is the constructor here? Let's go look at this. Takes in an iDictionary. I'm kind of amazed it doesn't let me do this. Read only requires 2. Requires 2 arguments. Oh, I have to tell it that it's a position pipe. There we go. Okay, so we're gonna make a read-only dictionary that is a view. So it creates what's called a view over this dictionary. So we still get all the fast access, but it's immutable, and maybe we'll change that later. I kind of like this parse. It feels pretty good. Let's validate this a little bit. Yeah, we'll validate it a little bit. Public void test parse maze, and we'll do day 10 dot or new or maze dot parse sample input, and this will give us a maze. Should be able to do maze dot pipes of new. This is where I like to do these. I wish I had my implicit casts here. New position of, and maybe I will just do this. Maybe I'll just go still my position from my Captain Coder. That's what I'm gonna do. GitHub Captain Coder. I'm gonna go to just my core. I'm gonna still in core. Let's find core. Search for my core repository. I want my position because my position has some nice things about it. Why am I so zoomed in here? Captain Coder. I just want to go find my position. I'm going to still this. Raw. We're going to pull this in to my project. New file position. Boom. And I didn't want to do that. Now I have to go find it again. For Captain Core, Captain Coder. What are my extensions on it? I don't remember what my extensions for position are. Position extensions. Oh, it just converts to mutable. I don't need this. Okay. So this is, we'll get rid of mutable position, this thing here. And I'm gonna get rid of this. Discrete, okay. And then I'll come back over to my day 10 puzzle and I'm gonna drop this version of position. Okay. So the reason I like the position I have here is I have a bunch of extensions for adding them together, finding the minimum of a bunch of one. So this is something I've written before. But the thing that I really like about it is I can do the following with my tests. I no longer have to, there's an implicit cast. If I do 5, 5, it's gonna automatically turn this. I can now do this, I can do the following. Position P equals 5, 5. There's some nice syntax stuff I've done to implicitly convert pairs of integers into a position. So that's the main thing I wanted, because writing out new position over and over is something I don't want to have to do because of no particular reason, but just because of reasons. All right, so let's test this thing here. I'm gonna go with a simpler input here. Oh, my start. I'm missing my start. When we encounter S, I'm glad I caught this. When we encounter S, here's my actual input. We need to do something smarter. Let me look at my actual input as well. Let's go find S here. What I could do is I could cheat and just go look up what S is. All right, so here's my S. Here's my S. Here. And I need to determine, so it looks like it's going up and left. No, I haven't. My parsing, I'm not parsing in S. I want that my S to be the correct shape. So in this case, my S happens to be a bottom right, I need to keep track of my start though. All right, so let's come back in. I'm not on part 2 yet. Sorry to excite you. Sorry, this will be position start, like that. Yeah, it's because I wasn't thinking about it here, and we're gonna say if, man, I thought I was gonna be really clever. I'm gonna say if CH is S, we need to have a start, position start equals default, and then start equals row column, and we need to determine the type of thing it is. I did part 1 reasonably quickly. It took me a long time to finish part 2 though. I'm not looking forward to it then. No, I am. I'm just nervous now. I'm nervous. It makes me nervous. All right, so we're inside of our record here. I'm gonna write a thing that's just called public static pipe determine start shape. All right, and we're gonna take in our string array maze and the position P position. All right, determine start shape here. And so now all I have to do is say, here's my start, and then pipe equals determine start shape of start. Determine start shape. Problem part 2 was that my console is TCL says TK based, and console for the maze just took, it took a long time just to print the maze. Interesting. What do I got going on here? There is no argument given. Oh, I have to give it my maze as well. Maze. All right. I'm really disliking this. I'm really disliking this. What I could do instead. I might do this. And then this all is fine. So we do this. And at the very end, we're gonna say pipes start. We can do some assertions here. Pipes start like that. We need to just put into our maze pipes of start is going to be equal determine start shape maze. Like this, maze and start. All right, we're gonna do it this way. I like this a little bit better. Yeah, so we're gonna go through, pull out each character. All right, and then this will determine it here. And it should be relatively easy. We need to look at our neighbors to determine if we're going. We need to look at our neighbors. So we're gonna get our neighbors. And then we need to determine what the pass through is on that. So I'm gonna create a care above care or care above is maze at position minus 1 row, no columns. Oh, and I can't. Let me have this take in this dictionary of pipes. This will be better. This will be easier for me. Maze here. Alright, and now this can take in our pipes. I'm probably already doing something way too complex. Why can't I do this? Can I implicitly convert? Oh, this should be a pipe above, below, to the left, and to the right. And I can cheat here, you know, notes, there is a hack here that doesn't account for being at the edge of a map. This has been bare. Oh, this isn't true. Because if there's a dot in that spot, man, okay. Let's write one more method. Public static you just hard coded it. Okay, I need to do maze dot try. All right, we're gonna make this. Maybe it makes sense to actually get the character out. Maybe it makes sense to get the character out. String array, okay. A little bit more annoying. All right, we're gonna do position above, position below, position left, and position right. So these are the positions surrounding the start position. And now I need to use this to determine the shape. So basically say if the character above, if Maze at above dot row above dot column is vertical bar, and Maze dot below dot row and below dot column is equal to a vertical bar. And it's not just vertical bar, it's vertical bar, or if it's above has a bar and anything that pipes in, or hang on. It's one of these. Bar JL dot contains this thing. Okay. Don't need the parentheses now. Okay. So if the thing above is a bar and the thing below pipes into it, we return we are also a vertical bar. What is, we're missing a parenthesis here. Okay. So it's a little bit more that if above is any number of vertical bar, a J, is that right? J, or an L won't work. A vertical bar or a J. Or a 7. Okay. So these are the things that pipe downward. So if you have something that pipes downward and something that pipes upward, then you're a vertical bar. Okay, so this is kind of annoying. String pipes down. J7 pipes down. Pipes up is vertical bar J or L. All right, so pipes down. So if we pipe down and pipes up, up here. Okay, so we have that. Why is J pipes down and not F? J pipe, oh, you're correct, F. This is why I did it this way. Up. No, F doesn't pipe. Hang on. F. Thank you for that. These are things that pipe upward. J has a pipe that connects, it pipes up. F doesn't pipe up. Hang on. I gotta write these down. I'm letting myself get confused here. My command station I have over onto the left here. Let's draw these out real quick. And then we'll convert it to characters. Here. Let's switch to my doc cam just so we can see it here. G, thank you for helping me with that. We want the following. And this is just for my own sanity. If I was going quick, I probably wouldn't parse this into a dictionary or anything like that. All right, so let's zoom in here. So we want the pipes that exits upwards. So any pipe that exits upward is like this. So this is vertical. So this is bar L and J. Pipe up. What tablet is this? This is a Remarkable 2. Remarkable 2. How's the visual? Is the font, is it auto detecting? Yeah, it's sort of zoomed up. All right. So things that pipe down is this one, that one, and that one. So this should be vertical bar, F, and 7. Pipes down. Things that pipe to the right. Let's keep this organized. To the right. That shape, and then that shape. So this should be dash L and F. Pipes right. And then the last one is pipes left. So we have this one, and this one. So pipes left is dash J and 7. All right, so this is pipes left. I had to write it out because my brain, the characters, I hate the characters that were chosen here. They're potentially better. I don't know that there are better ASCII letters, but there is ASCII art that has those symbols, but maybe they chose not to do it because it's not part of the default lexicon or something. For like, you need like extended ASCII or something. I don't know. I'm pretty sure it's an extended ASCII. The problem is just that J in the font is bad. It hurts my brain. Oh, you're probably right, G. It's my particular J. Looks like a square bracket. Kawi, Kawaii. I think it's a Kawaii. Welcome back to the stream. And Pax Pagin, Pax Pagin, Pax Pagin, Pax Pagin. I would like to welcome you today. Welcome to the crew, and thank you for following me. Pax Pagin. If I'm pronouncing it wrong, feel free to correct me. But thank you so much for being here. Happy Sunday. All right, but I wrote it out. Bar LJ should be pipes up. Pipes up. Pipes down is bar F7. It does. It's my brain can't handle it. You're absolutely right. It does specify which directions it pipes to. But I was struggling to convert that here. I had to draw it out because I couldn't handle it. Pipes left is going to be dash J7. All right, so these are here, and so what we're gonna say is if up pipes down, if above pipes down, and below pipes up, we are vertical. That's essentially what we have. And then the other option is we need to figure out, okay, so if up care above is equal to maze. Kawaii, thank you for the doi. I'm just having trouble with my brain handling it. Care pipe above is, or space above. I don't like what I've written here. I'm gonna say if pipes down, if the space above us pipes down, space below and the space below. There we go. I'm gonna say if then we're vertical. Elsewhere horizontal. Oh, no, we can end up, we can end up in a variety. There are 6 different options, right? There are 6 different options. Okay, so if left pipes right, I hate this. If left piped right, oh, I could just manually go in and figure it out, which is what I've kind of done. Let's write this because it has to work for my sample input as well. If left pipes right and right pipes left, we are horizontal. And all I really have to do is check that it worked for my sample input and my, so we're gonna say if, can I write an extension method here? Public static class extensions. Do I need to put them here? Public static bool pipes left. This char ch goes to static public static up pipes, down pipes, right pipes, left pipes. So the character pipes left if left pipes dot contains ch. Pipes up pipes, pipes down. Pipe down is a funny, just sounds funny to me. Down pipes, and then the last one is pipes right pipes. Okay, so now I should be able to say if, get rid of you. I did this to try and make it easier to read. Space above dot pipes down and space below dot pipes up. Then we are a vertical pipe. So now I can write it like this, and it just reads a little bit easier for me to understand. And let's do a switch. We're gonna return on, man, I don't know if I can do this as a nice switch. Else if, well, we're just gonna return, so I'm gonna do the else. All right, so then we just gotta check which direction we're piping through. If, space left, space right, maze dot left, right. Okay. If the space above dot pipe down and the space to the left pipes right. So if the space above is coming down and the space below is coming in, we have a bottom, we have a bottom left. Let me draw these out just so my brain can handle it again. Doc. All right, so we're saying if we have something that pipes down here, we have an X here, and something that pipes in here, we must be this shape. We must be, and this is bottom right. This is bottom right. So this is going to return pipe dot bottom right. Turn off my dock cam again. Sorry. This is where my brain struggles. My brain struggles. All right. So if above pipe down, and do I even need this for a breadth first search? I don't think I actually need this. It's just good to know in my mind. Actually, I could just start at the start and then I breadth first search out. I don't think it actually matters. Bad cop. I have a strategy for part 1. We're still parsing it in. We'll start parsing it in, and I think I'm going down a rabbit hole, but I'm gonna keep going. I think I'm gonna go down this rabbit hole. I think I'm parsing something. I'm doing something that I don't need to do. I haven't gotten to part 2, so hang tight. Don't give me any spoilers just yet, because I don't know what it is. If pipe above pipes then and left pipes right, we are bottom right. I appreciate it. If space above dot pipes down and space right dot pipes left, and I'm sure they've constructed this in a way, then we're a bottom left. All right, so these are all the ones. Just prepare yourself. Don't worry, I'll clench. I'll clench as tight as I can once I get to it, just to make sure nothing comes out. Pipes down and right, pipes left. All right, we have 3 more cases. We have 3 more cases. If space below, not pipes up. And Rain, welcome back. How's the maze going? It's amazing. I didn't come up with that joke. Corfless. I'm sure many people did it, but Corfless is the one that said it first. Space to the right dot pipes left. So this means we're coming from the right down. So this would be a top left. Return pipe dot top left. And then if so this is this shape. F, we have something that comes this way, and something that this little comment here is a little bit better. Something that comes this way. All right. But Bad Cop and Rain, welcome back to the stream. I'm glad you guys are here. I hope you are having a beautiful day. Below dot pipes up. And space left dot pipes right. Return a pipe dot top right. Because this one is the space below is piping up. And we have a 7, and this one is piping. Oh, hang on. And this one, space to the left, is piping in. So it's this sort of shape. Tim Baudet, how you doing, buddy? Welcome back to the stream, folks. You guys know Tim Baudet is an incredibly amazing person. Your head hurts. I'm sorry to hear that. I hope it's from thinking too hard and not for any other reason. But everyone, do you guys know Tim Baudet? Tim Baudet. I would say Tim Baudet. It's Tim Baudet, right? Baudet. Incredible streamer, full-time streamer, full-time indie game dev. Folks, attention all lurkers. Attention all lurkers. Please direct your attention to the chat. We have a very important guest with us today, Tim Baudet. Incredible streamer. He's created his own game engine in C++. Racing game extraordinaire. Tim, if you got any links for us, I think you already permitted, but if you got any links for us, feel free to drop them in the chat. Your game is amazing. But yeah, feel free to drop a link to your Steam page for us. I know you're working on your game engine channel, but guys, be sure to follow Tim Bodett, one of my favorite streamers. I love Tim Bodett, but welcome. But yeah, I hope you feel better soon. I'm sorry your head's hurting. All right, so this is our top right here. And then I think the last one is like this. If space left dot pipes right and space dot right space right dot pipes left, and return pipe dot horizontal. I think this is all the case, and I'm gonna do a throw new exception. Could not determine starting pipe. Excuse me. Tim Bodett says, trying to get prefab support into my editor, and that requires a lot of deep thinking and edge cases. Ugh. Actually doing a little testing code too, nearly test-driven development, but not strictly TDD. Yeah, I tend to do, as a joke, I'm gonna say I tend to do hope-driven development, but that's not entirely true. I do, when something fails, write a test, or when something is complex enough, I want my brain to be able to handle it a little bit. Okay, so this should determine what our start shape is. But Tim, we're working on the advent of code today. I think you're probably familiar with advent of code. Our puzzle today is we are given this ASCII input, this text input that defines a maze. Pagorli, welcome back to the stream. It defines a maze, a loop. It actually is going to define a loop. I wish I was learning Tetra. I want to build a toy database, so learning C. Ooh, Dota, welcome back to the stream. But yeah, we have this garbage input that doesn't know everything well. But the start position, I was just determining the shape of it. With high complexity or high risk, high cost fail. So Tim, I will when something fails, and I will usually write a test if I have something in my code failing. If I find a bug, I try to write a test, and it's not always possible to do this with like game development, but usually like logic development. I try and write a test to expose that bug and fix it. And then I go and I refactor. That's usually what I do. Dota, we missed this month because I'm doing advent of code. So I needed to, because I'm doing advent of code every day this month, I decided not to do it this month, but we'll be back in January. Bad Cop, did I not say hi? I swear I recognize that. I made a visualization today because this problem was really neat. Oh, cool. You said hi, I said hi before you came in. You were talking about spoilers, I apologize. Bad Cop, points. Bad Cop, if I missed you, I didn't mean to make you feel bad. Here's 50 points to you. Hope it's literally the least I could do. But Topologist, welcome back. Actually, part 2 is not super hard if you have advanced knowledge in topology, which clearly you do. Yeah, I'm expecting part 2 to be something nuts like the animal we're searching for is a ghost and can travel through time and space. Oh, Tim didn't say hi to you, Bad Cop. Gotcha. Yeah, Tim, all of Tim's turtles seem to be here. Tim has some of the best emotes too. I think this one might be my favorite. Tim driving. I love it. Okay, let me come in here. Yeah, some good ones. Okay. Just to make sure I got this, let's check our starting here, our start pipe, just for a sanity check. Our starting pipe's at position row 0, 1, 2, row 2, column 0, dot should be. This should be a pipe that goes top left pipe. I feel like I might need to rename these. I might need to rename these for my own sanity. I'm already feeling like I'm not going to be able to handle this. Test parse maze sample input. Sample input. There we go. All right, let's test the spot next to it. That's this J. And this one should be a bottom right. Like that. Like my brain is wanting to say it makes a J shape. So I'm feeling like I might actually want to do a J pipe or just pipe J. So the J here and then the L top left. Yeah, I'm not sure the best way to do this. But bottom right feels like it makes sense because it curves bottom right. I don't know. I need better names for these because this is going to confuse the heck out of me. And then bottom right is going to come up to this one here. So we come up a row like this. Bad cop. That's what I was saying. I was hating it. I also don't know what to call them. I don't know what to call them. This should be an F pipe. It goes. So this is our top left again. Enjoy your walk, G. Thank you so much for hanging out with us. Have a beautiful day. We'll see you next time. And I'm just gonna traverse over this. I'm gonna change. Actually, I want I want this input as my test here. I'm gonna do this input as my test. It has everything in it. Public static string sample input simple. We'll trim this like that. Okay, and I'm gonna do sample input simple here, and instead I'll check this one out. Let me just copy this down here. Maybe even put this directly into here. All right, we'll comment that out. And really, this is now I'll just go through all the positions. Position. This is position 1, comma 1. It's still top left. Position 1, comma 2 should be horizontal. Position 1, comma 3 is this 7. This should be top right. 2, comma 3 should be vertical. 3, comma 3 should be bottom right. This is where these names come from. It's like the bottom right. A rarity on Twitch, Tizarnal. Let me know if I pronounced that incorrectly. Welcome to the stream. But yes, we are doing Advent of Code here. We're still on part 1. I'm over-engineering it as usual. As usual, a little bit of over-engineering, maybe a lot. Bottom left here. And then the last one we'll check here is this should be a vertical pipe. All right, let's set this up as a test. Fact. Let's make sure we build. And this should build vertical. There we go. Wasn't gonna build because I didn't type the right thing. The autocomplete got me. But happy Sunday. I'm glad you're here. .NET Test. This one's still gonna fail, but hopefully, all right, so our parse is passing, which gives me some confidence that we're parsing things incorrectly. I'm gonna be really sad if we're not. Okay. I'm gonna be really sad if we're not. The next thing I need, because I wanna do a breadth first search, is given a position in the maze, I want to get the neighbors of that position. So given a position in the maze, I want to get the, One thing I want to do actually first, just to make sure my start is getting parsed in properly, let me get my input here. This is my actual input. Input.txt. And I'm going to put this also in my test folder. The files to paste have been deleted. What? Still there. Why did they get deleted? No, it's still there. All right. So this is our input in our test. Let's come up into our day 10 test. We'll do a public static string input is equal to file.read all text of input.txt. So we're going to load that in, and I just want to do some assertions on here because we tech fact public void test maze start shape. Really, I only care about our maze's start shape. And we determined, if I find the S in here, we determined that my start shape should be a bottom right. Hang on, is that true? Yeah, so we have the F here. This means we're coming across. We're coming in from the right and we're exiting going up. So we want to verify that for my input that we are a bottom right. So we should be able to parse this. Toak doing the same one. Toak Fodai, welcome back to the stream. I hope you are having a beautiful day. This should be on our puzzle input. I'm gonna rename this to puzzle input. And then we want to say maze.start. This is gonna be the position that we're starting at. We're gonna do maze.pipes of maze.start.should be. And this should be, we determined that this was specifically a maze.bottom right. Let's reload our tests here. Let's make sure we build. Reload the test, and I want to run these tests here. We don't build, I missed a semicolon. All right, try again. But yeah, how have you doing the same challenge? Toak, how have you been doing on the puzzles so far? This is our first like pathfinding one, or like true maze one. Okay, test start shape. We got the wrong start shape. Was vertical, pipe was vertical, but we expected to be bottom right. Let me validate that I'm not insane here. So our start here has an F on the left. So we're coming in F on the left, and then a 7 on the top. Drawing this out on my Remarkable real quick. So we have our X here, 7 on the top. We have an F here. On the right-hand side, we also have an F, and below, we have a 7. All right. So yeah, we should, the only one that makes sense, so if I go to my doc cam, this is what I just drew. This is what I just drew. I drew this thing here. This is the input we have. Somehow, I have a bug in here. It should be detecting this, but it's not. So I don't understand what it does. 100 millisecond execution time so far, not bad, not bad. I'm still working on part 1. I have a bug in determining my shape here. I'm gonna put a breakpoint here. We're gonna debug test maze start shape. We're gonna debug this test. Because I have a bug here. So I gotta look. That is the Remarkable 2. Remarkable 2, it's kind of an expensive tablet. It's an expensive tablet. All right, took 90 seconds, oof. That's a big one. If you do breadth first search, it should be quick. It should be quicker. All right, so I want to just make sure that we have all the right things in here. All right, so above is a 7, below is a 7, left is an F, and right is a vertical bar. I got the wrong input. I just wrote the wrong thing down on mine. All right, so we have the correct things here. If we pipe above pipes down, and the pipe below should not pipe up. So pipe below dot pipes up is returning the wrong thing, I believe. All right, so space above, pipes down, given a character, down pipes should be bar F7. So it pipes down. So I've done something wrong here. I've done something wrong here. Let me look here. So space above, space above is a 7. Space above is a 7. And so does pipes up pipes should be bar. All right, here it is. Bar LJ. Bar LJ. I put the wrong thing here. Pipes up should bar LJ. All right, let's exit our tests and try again. There we go. So at the very least, I know we have the right shape for our maze, and I feel pretty confident that we're parsing in the maze properly. So I have my maze parsed in. Now we need to do a breadth first search. Before I can do that, let's go look at the just a general algorithm for breadth first search. Breadth first search. It's pretty straightforward. I'm gonna do breadth first search here. Cheats and Arnold said, I didn't realize e-ink note device had gotten that precise. Oh, this one is so good. I absolutely love it. And this is the algorithm I want to implement. And it says, I'm gonna give it the start so I know where I start. We have a queue and then we explore things. We say, find, the part here is we gotta find our neighbors. And so I need to write a method that is going to allow us to take a position in our maze and get me the neighbor positions of it. And so this is a pretty straightforward procedure, straightforward function to write, so long as I have this. So I need to get the adjacent edges to it. And so I need to write here in my maze. In my maze, I need to have a neighbors. I'm gonna have a neighbor. So public static enumerable of position neighbors. Neighbors is gonna take in just a position because I don't need to make this. This is gonna be a non-static method so we can just use pipes here. We're gonna take in a position, and it's gonna return to us all of the things that we can move into that's next to us. So we get our pipe shape. So our pipe shape is gonna be pipe here. Pipe is gonna be our maze at our current position. Okay, what did I call it? I called it pipes. Okay, so what shape do we have? And now we can basically, when we know what shape we have, we know the neighbors that we need to check, and we need to determine if those neighbors also pipe. If those neighbors pipe into us, then they are neighbors. So every spot will have 2 neighbors, up to 2 neighbors. In fact, because we are this is interesting, because we are a loop, we know for sure that we have exactly 2 neighbors. We will always have 2 neighbors, which is really interesting. And so I actually don't think I need to even check that the other pipes, that's interesting. I don't even have to check if the other pipes are there. I just know they are because of the definition of the puzzle, which is cool. So we can do the following. We can do return pipe switch. And we're gonna say if we are a pipe dot vertical, we can return a new I'm just gonna go with array here of size 2, and it's gonna be position minus 1, 0, and position plus 1, 0. So these are the positions above and below us. If we're going up and down, it's position above and below us. This is neat. If we are horizontal, we return the positions to the left and to the right. Okay. If we are a bottom left, so bottom left, we return above and to the right. So this one is above, and this one is to the right. If we are, saying I can get rid of this. Ooh, no, we can't. I can do this. Okay, I can get rid of the word position. I don't know if I like that. Can I get rid of new altogether? Hang on. And just do this. What is it telling me here? It's like graying out something. Simplified. Collection of visualization can be simplified. Is it telling me how can it be simplified? I'm trying to understand. I can do that. And then it continues to say it can be simplified further. Can I do just new? I don't understand the simplification here. Let's look at the simplification. IDE 300. Cool. I'm gonna leave it for now. Because I don't know what simplification it's referring to. Control dot will complete it. Use collection expression. I swear I just tried this. Auto. Thank you for that. I swear I just did this. That's interesting. Okay. Okay. I like it. Bottom right. Again, so bottom right is we have above and to the left. Like that. Top right. I'm gonna say we have one below. Keep in mind, +1 is below. Here for me. Because I'm doing row and column, so down is +1 in that position. Top right, and then to the left. And then finally, top left is below and to the right. So if I'm a top left pipe, I'm going that way. And my camera is reversed, I think. So when I go to the right, it's my right, not the right you're seeing. It's not mirror right. And if we get here, we'll go ahead and throw an exception. Throw new exception. Could not determine neighbors. All right. And we can just do it this position. And really, there's some conditional checking we can put in here for illegal positions, but we're gonna say our input is gonna be valid, is essentially how I feel. I'm happy to see that I'm not the only person who has to reason out the plus and minus of the direction of the grid. Yeah, I like to use row and column because using X and Y kills my brain. Yeah, row and column kills my brain. All right, so now we have our neighbors. We should be able to determine on our maze. I'm gonna do the following: public void, void's not right, object. I'm not sure what I'm returning just yet. This is gonna be my breadth first search. Search. Or walk. I'm gonna call it walk. It's gonna walk the maze. It's gonna walk the maze. And we're gonna determine, basically we wanna determine the furthest position. So I have to think about this a little bit. We're gonna walk here though. And really the thing I kind of want to get back is given a dictionary of position to int, which is, or I'll do long because Advent of Code likes longs. Given a position in the map, how far away is it from the start? That's what we're doing here. We don't care about the path, we only care about the distance in this one. So given a position, how far away are we from the start? Dictionary position long distances equals new. At the end, we're going to return our distances. And now I want to implement breadth first search. And I'm a little, if we do breadth first search, here, I'm gonna copy this just so I have the template here for me. Josh, I'll read that in just a moment. Josh, let's check out what you're saying. This is the standard breadth first search. Josh says, I'm getting a ton of rejections from companies. I have projects, but not getting any calls. Can you give me some advice? It's rough. Optimize your resume. Optimize your cover letter. Your resume, you know, that's a big part of it. Optimize your resume, optimize your cover letter. Don't just send the same resume and the same cover letter to every company. Look at the company and say, what do I like about this company? As a person who has hired people, the people that I really prefer to hire are those that know a little bit about the company, that don't send it out to a million things, because I know that you are just gonna, you know, kind of want to be this is the wrong word for it, but like cog in the machine. I am more interested in someone who is interested in the type of work my company is doing. Let me give you a permit here. Sorry about that. Thank you for letting me know the audio is too loud. I forgot there's a button that mutes it there. Otto, thank you for that. I don't know how long that's been going, but I apologize, everyone, for the super loud music. Josh, here is I permitted you to post links here. I'm gonna take a look at that on my other screen real quick. Full stack web dev. So like this looks pretty, your website here looks pretty nice. It doesn't look bad. I don't have enough time to like give you a full review on it. But what I will say is your work history is very short. And that's okay, because you're looking for like an entry-level dev position. Your project, you have projects here, you have other stuff. It shows you have GitHub experience. Here's what I'm looking at, folks. Josh sent us this website. This is your portfolio, and there's nothing wrong with this. So what I would say, are you just sending people this, or what does your resume look like? There's a question like, what does your resume look like? So like, if you're trying to just go straight into web dev type stuff, this is probably pretty good. I want to know what your work experience is. This is really short work experience. May 2023. If your resume, if this is your latest work experience, it's okay. It's just the type of jobs are gonna be a little bit different that you can try and get into. But yeah, optimize it. Your cover letter, I don't think most people realize how important the cover letter is. Your cover letter should say something along the lines of, I love what your company is doing. I'm really excited that you're doing these types of projects, machine learning, web dev, these things. I think I would love to learn more. And I think that it would be mutually beneficial for everyone involved. So you'd say something like, I would love the opportunity to work here, and I think that it would be a very good experience for me to learn something. But not only that, but I think I would provide this value. Here's the value I would provide to the company, and here's the value that the company would provide for me. That's sort of the best cover letters I've seen do that. Hextree, welcome back to the stream. Yeah, Josh, so you're going to be applying to the entry level, and that means that you're fighting against a million other people. Shout out to Hextree. Thank you so much for the raid. How are you doing today? What were you doing? Were you working on admin of code, folks? Attention all lurkers. We got the incredible, the fabulous, the insanely amazing Hextree. They're not a quad tree. They're not a binary tree. They're a hex tree. Did you guys know that hexagons are the bestagons? And Hextree is the best tree out there. So give them some love. Give them some love. How are you doing today? Were you working on Advent of Code Hextree? But yeah, Josh, you don't have to have a solid work history. It's just you need to say what sets you apart from all the other people applying. And one way you could do that is in a cover letter. And then optimize that resume. Optimize the resume for sure. I finished day 10, got there in the end 2 hours, but a few nasty edge cases. Gotcha. We're about to write binary, sorry, not binary search, breadth first search here. We've done our parsing. We set our thing up. I'm going way overkill on this thing, I think. But we're going to do a breadth first search now. Here. So we're going to try and follow the generic. I have this here because I will forget. But Josh, if you want to hop on the Discord too, if you have a resume, remove all of your publicly identifying information, post it on the Discord in the ask for help, and we can get some people reviewing your resume and let you know, like, hey, here's some changes you can make here. And keep in mind that changing your resume per company, changing your cover letter per company is a good idea. You will get more bites if someone looks at your resume and says, oh, it's this specific job. Don't just blast that resume to all the different places. Optimize your resume for the job that you want. Because the HR people and then the engineer or someone who ends up looking at your resume, they can tell. They can really tell when you've just blasted it to 1,000 different places. That's not going to be helpful for you. They're looking for something unique. Gotcha. Hextree, congratulations on your stars. We're going to do a queue here. So I'm going to do queue of position. Queue. New queue. So we have a queue of positions. We need a hash set of position explored. New hash set here. So we have our queue. These are the things that we've explored. We are going to say that we're starting at our start here. So our start explored dot add start. This is the position we're starting at. Queue dot in queue start. And notice I'm following this procedure here just to do a basic breadth first search, and then I might modify it a little bit. And we're going to say, well, our queue, so I'm on line 5 here. Well, our queue dot count is greater than 0. So, well, our queue is not empty. Well, our queue is not empty. We are going to get the node out. This is a position that we're going to explore. Position exploring is going to be equal to our, they call it V for visited probably. Queue dot the queue. We are not looking for a goal in this one. In this one, we are literally putting steps. We are just filling out. We don't know where the end is, so we don't have this part here. We don't check if we're at the end. Instead, we need to do a thing here. It says update, how many steps have we taken? There's this thing here we have to calculate how many steps we've taken from the front position. So we kind of need to, I think if we remember where we came from, we'll be okay. So one thing I can do as well as distances of the start is equal to 0. So we want to be able to say, okay, well, go back, or maybe the positions we're going. What I'm going to do is I'm going to say my neighbors. I'm going to go ahead and add them in first. I'm going to add them in first. All right. Like this. So it's not quite this, but now we're going to go through all the edges. Say for each neighbor, we have a thing for each position neighbor. Really, we're just going to have 2 here, which is kind of nice. In neighbors of the position we're exploring. So go through our neighbors. If we have already explored this neighbor, we've already been here. Explored dot if explored contains our neighbor, don't go there again. Continue. Just go to the next thing. Don't re-add it. So now here is saying, what should we do if we haven't explored it yet? And so we are going to first update our distances for our neighbor. And then the distance to our neighbor is 1 plus our distance from where we are exploring plus 1. So keep in mind, this is going to say we're going to get to our neighbor, we have to take 1 more step. And maybe current is a better name here. We get the neighbors to our current. What is the distance from our current here? And we could pull it out here. Steps to neighbor, like this. But I feel like it reads better if I have this here. Right, so we're gonna take a step out to our neighbor here. And then we need to actually explore those nodes. So I'm gonna do q dot enqueue neighbor. So we're gonna say we need to explore that node next. And then we also need to say, okay, and by the way, now we've explored, is that right? It's not explored, mark it as explored. Okay. We're gonna add in our neighbor here. Feels weird. I feel like I should explore it here, but in this queue here, we'll do it. This one's keeping track of our parents, so we can track the path we went on. We don't care about the path, so we're gonna know it. Ignore it. Instead, we say how far, how many steps have we taken to this thing? And at the end, we get distances. So I think we have our walk here done. And so let's come to our part 1, which is way up here. And we're gonna do maze is equal to maze.parse our input. And then we're gonna do maze.walk, and then we just want to find the biggest value, max. I'll go to values dot max. So this is the thing that's furthest from the maze. So we walk the maze, and then we can get the values out, and then we get the max. Did we just solve part 1? All that setup to hopefully do it, have it easy here. Do I have a bug? .NET build. Okay, let's run our tests. Come on, give us some good news. Come on, give us some good news, and we failed. All right, some bad news, folks. Sample input is not null here. Index was out of bounds. No. All right. An index was out of bounds. Doesn't give me more information. Let's do a .NET test here. That makes sense because if I'm on the edge here, okay. All right. I know what's going on. In my neighbors, I need to do a try. I can't just get these positions. All right, so here, if our position is outside of the maze, We only want positions that are inside the maze. So I'm gonna do where possible, and then let's do this. Possible, and then I'm just gonna do a filter on it. Return possible.where pipes.contains position. Position goes to. We don't have pipes here. Does not contain addition for contains. Contains key. Okay. Okay, so we can do this. We're gonna say only keep the positions that are inside of the pipe that we've parsed in. I believe this will help us not have an index out of bounds. Still failing. Index was out of bounds. Okay, so I don't know. I need to figure out where it is. Let's debug this to get more information. I guess I could have did a .NET test in the terminal. It should fail here. And it's inside of determine start shape. What? We had line 131. Hang on. This is weird. .NET test. Use possible question mark. I don't understand auto. We are failing here. Oh, here we're on the. This shouldn't matter. It does matter because we have that on the left. Okay, so if we're on the left side, okay. Remember, no, this doesn't account for being on the edge of the map right here. So no, this does not account for being on the edge of the map. Yeah, that was a mistake I made. Whimsically made, welcome back to the stream. How you doing? Welcome to the stream. So of course it's not gonna work for this one. A hack is to put dots on the edge. Unless I'm too late already. No, we're working on it. We're working on a solution. I think we're about to finish part 1. We're about to finish part 1, then we're gonna take a break. There we go. I just hacked the left in there. All right. We're gonna put. All right. We're about to do part 1, or we think we're about to solve test puzzle input part 1. We think we are about to solve part 1. Puzzle input. And I could have been much lazier and not built out this whole data structure for it. I could have just done it directly on the map that was there. I think we have this as our solution. We're gonna go test it here. Submit. There we go. 1 gold star. We got the first one. Do you want the solution for part 1, Whimsically Made? So we got a solution to part 1. Git status, git add, git commit -m, feat, implement day 10 part 1. All right, folks, I just followed the pipes route. Yeah, I could have not done all this extra stuff here. I could have directly done this walk. I think you parse them into a graph structure you've defined and then perform some search on. Exactly. So I built out a maze data structure that has all of my pipes in it and my start. And then I just did a walk. And my walk determines the positions, the distance to each position in it. Since Zarnal says, since I've done quite a bit of AOSA, I have a slowly built up over time grid of T-class that makes stuff this a lot more convenient. Yeah, if I had some data structure here, be like, Code Monk, thank you for the star. I appreciate that. But yeah, I just did breadth first search on the maze. So we start at our start, and breadth first search is the wrong word. We do a flood fill. We do a flood fill from our start position, okay? And the flood fill just increases by 1 every step. So at the end of the day, we have all these in here because we're not trying to find, there's no exit defined in the maze. We're trying to find the distance, the furthest distance. So this would be more likely called a flood fill. It's really more of linked list traversal, something like that, yeah. Because they all connect, it's all cyclical. But I did a flood fill here. You probably could have, you know, a very simple solution to this that I didn't think of would be to just count the number of nodes in the pipe and then divide by 2. That would have been a really easy solution, actually. To I'm realizing right now, you could have just counted all the pipes in the path and then divided by 2. That would have worked. I did a traversal. Smab, I wish I had thought of that. Yeah, if you just count all the number of pipes in it, you'd get it. I think you still have to do a flood fill. Go both directions. That's a really cool solution. Bad Cop, that's a really cool solution to part 1 is you just go both directions until you're at the same position, and that's the furthest distance. Yeah. All right, folks, we're going to take a break. Excuse me on that hiccup. I'm going to read part 2. A quick break, just because I need to top off my coffee here. We've been going for 2 hours. 2 hours is my maximum without taking a break. I'm going to top off my fresh water. I'm going to top off my... It's not going to force me to do the path. Well, we'll find out. I'm going to top off my bean water. I have no bean water. I'm empty. But we're going to get some more bean water. We're going to get some more fresh water. I'm going to take a quick break. I'll be back in 2-3 minutes. Just got to fill up my water bottle here. But we'll be back. And folks, when we come back, we're going to get some stretching in. We're going to take care of our bodies. We're going to love ourselves the way we deserve to be loved. So, get your mom on the phone. Hey, Mom, Captain wants you to do some stretches with us. Get your mom, get your dad, get your cousin, get little Bobby, get little Susie. Get your bears. Have them bear with us. We're going to come back. We're going to do some stretches. So hang tight, folks. We shall return. All right, everybody, the captain's back. I want to welcome Tech to the crew. I think it's T3CKK. I think that's Tech. If I'm pronouncing it wrong, let me know. But Tech, you know you followed me today. We've got Tech following me, and I'd like to thank you muchly. Thank you so much for the follow, Tech. Welcome aboard. Welcome to Captain Coders Academy. Folks, before we hop back into it, thank you for the Doi. Thank you for the Doi, Proton. Before we hop back into it, we got to get some stretching in. I try not to go longer than 2 hours. Every 90 minutes, I try and stop, take a break. We were feeling close. I just kept going. But I'm going to encourage you to stand on up with me. Get everyone around you. If you're at work, get your co-workers to stretch. Stand on up. Because, look, the captain loves you. Which means you should love you.
Back.
And if
Pay
you
attention.
love you, you got to love yourself. And one way you can love yourself is by getting some stretches in, taking care of that body. So please, if you'd stand on up with me, get some stretches in, take those hands, put them above your head, and do a nice little lean back. Just a nice little, don't lean back too far, you don't want to hurt anything, and you're just going to hold this, engage your core. Engage your core and lean back just slowly, and then you're going to hold it here for, 10 seconds, folks. Just nice little gentle back stretch there, and then slowly bring it back up. Wasn't that nice? One more time, bring it back, slowly lean back, feel that stretch in your back, engage that core, keep yourself, don't fall over, be careful, if it hurts, stop, and bring it back up. Nicely done. Doesn't that feel good? Let's do some shoulder rolls, people. Take those shoulders, roll them up, back, and down. We're gonna roll them back. 2, 3, 4. Add your elbows. Yeah. 2, 3, 4. Full arms. 2, 3, 4. Bring them forward. 2, 3, 4. Add the elbows. Yeah. 2, 3, 4. Full arms. 2, 3, 4. Shake it out. Shake it out. Doesn't it feel good to be alive, folks? Get those arms up at the side. We're going to do some slight trunk rotations back and forth. Nice and slow. Feet shoulder width apart. Don't snap. Don't swing back and forth super fast. Nice and slow. And get that nice lower trunk stretched in. I'm actually gonna start leaning into it down. Zoom out a little bit. Sorry. I'm a little too zoomed in. You can't quite see me. Zoom out just a little bit here. Pull my pants up. Pull my pants up so nothing terrible happens. All right, and I'm gonna get back here so you can see me. We're gonna stretch down into the left, and then bring it up into the center, and then down into the right. Just nice, gentle rotations. Get that trunk. I have a little bit of a lower back stretch that I wanted to get in here. Feeling tight. And this just should feel wonderful on your lower back. All right, folks. Let's hop back into it. Thank you guys so much for joining me in those stretches. I hope you did. I hope you're loving yourself. Hoping you're loving your body because you're a lovely person. We got a little too close. But for joining me in those stretch points at all. 250 points to all you beautiful people. We're gonna hop back in here to day 10. We got our first star. Let's do a points at all for being here to watch me complete part 125 points. Let's check out part 2. Here we go. Take a deep breath of water here. Take a deep drink of water. Oh man, apparently I'm really tired. I can't even talk today. Take a nice big swig of water. Oh yeah. Gotta hydrate here. My coffee's ready to go as well. Take a nice small sip of coffee. Oh, Don Francisco, you did it again. You've done it again. Part 2. You quickly reach the farthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. All right, so we're gonna find the number of tiles that are on the inside of our loop. We should be able to do a flood fill from the out. Let me keep reading. When you do a flood fill from the outside, it should fill in all the spaces that are outside of the loop, and then we do the invert, then we find all the ones that are not there. So I think we can do this one. Let's keep reading. The above loop encloses merely 4 tiles. The 2 pairs, yeah. So if we did a flood fill from the outside, we'll fill in all of the spaces here. There's a bunch of junk laying around. So what we need to do is we need to say, what are the parts of our loop? What are the parts of our loop that are actually part of it? And then we sort of blank out all the other ones, and we'll do a flood fill in all the dots, and then we find all the dots that are not filled in. That's our inner ones. In fact, there doesn't even need to be a full tile path to the outside for tiles to count as outside the loop. Squeezing between gaps is also allowed here. Squeezing between gaps is allowed here. Oh. Flood fill. We still want to do some kind. We want to do a. We want to do a flood fill. I want to do a flood fill. But I can't just do it on our basic input. I'm gonna have to construct something that can do a flood fill, because I can't just do it on this grid because there's space here. So you need to like determine. We need to do like on the half points. Oh my goodness. In the above example, it's just about the topology of the outer loop, which separates the plane into 2 parts. Topologist says we can do the topology. Yeah, we separate it into 2 parts. So that's an interesting thought. That's an interesting thought. In both of the examples, I'm gonna think about that, topologist. That's an interesting thought. It's like you step up. I'm gonna look at it. I'm gonna think about it a little bit. Here's a larger example, which is a little bit hard to read here. This will probably be a sample input. The above sketch has many random bits of ground. Yeah, we knew there was gonna be extra garbage in there, so we're gonna get rid of the garbage. Some are in the loop and some of which are outside of it. Okay, in this larger example, 8 tiles are enclosed in the loop. Any tile that isn't. Yeah, the topology could be interesting. I have to think about that a little bit. I want to do I still think I can do a flood fill if I'm clever, and that will be easy for me. Here's another example with many bits of junk pipe laying around that aren't connected to the main loop at all. But I'm going to think about topology because I haven't considered that. But it also would be a solution that here are just the tiles that are enclosed by the loop. Yeah. I think we just get rid of all the junk tiles. The topology is interesting. It's an interesting thought. In the last example, 10 tiles are enclosed by the loop. Here are just the tiles that are enclosed by the loop. So this is the sample input 2 and our output send. Let's write a test here for this. Nice, congratulations, Smab. We're gonna call this public static. So we actually don't even care about the start on the second one. We care about the space internal. Public static string sample input part 2. Topology is interesting. So topologist, you weren't kidding. You weren't kidding when you said you understand topology. So here's our sample input 2. And public void test sample input part 2. Create a fact here. Fact. Puzzle input should be part 2. Sample input part 2. Yeah, I thought you were just saying that this should be 10. Alright, so this will fail. Let's create a part 10. Probably put it somewhere dumb. Part 2. Oh, it didn't. Input here. So topology is interesting. I want to take my maze and like strip out all the extra garbage though. You Dacky, thank you for the follow today. Oh, you Dacky, welcome to the stream. Welcome to the crew, my friend. Thank you for the follow. Tazar announced that I came up with a really dumb solution to this that works because it's just stupid enough to be fast. Sometimes that's all you need. Sometimes that's all you need. This one's interesting because we're not walking it anymore. I want to write a method that gets rid of all the garbage first. I want to get rid of all the extra garbage first. Let's make sure my tests runs. Let's make sure we build .NET build. And then we'll run these. And I should fail. It should just throw an exception. Test puzzle input part 1. All right, let's run these. They should all pass except for this new input one here should fail. Okay. I really think I can do a flood fill. Topology is interesting. I don't know enough about it. I think I'm gonna try flood fill first, and then come back to the idea of topology. Let me think about it though. We could do, to do the topology, I still need to get rid of all the extra garbage. I need to get rid of all the extra garbage. And what we can do with the topology is if we're on a pipe, so here's the thing, I think if we're on a pipe, I still don't know. I guess we could do like okay, we do a flood fill to get the base, so we do zeros. These would be zeros on the outside. I don't understand how to do the topology here, because you would step across. I want to mark these as a 0 height. From here, I don't quite understand the topology method you're talking about. We could do a flood fill on the outside. So we have all the outside. And then we know that the next step is onto a pipe. Everything must be onto a pipe. And then the next step, so you do a flood fill on the outside, then you do a flood fill that just does pipes. And so you have like an outside layer of pipes. Anything, and then you need to like say on, off, something. To form a point and check if it's inside the curve or not. Yeah, I don't understand the topology solution. My idea is still to do a flood fill with the topology approach. A topologist, I'm absolutely looking forward to looking at your solution. I really want to look at your solution and think about it a little more. I think I can still do a flood fill where I flood fill the space between tiles. So I flood fill the space between tiles, so it'll fill up here, and the space between tiles gets full. I think I can do a flood fill between the space of tiles, because keep in mind, like the space here, if we zoom in here, the space, we really want to think of this, all of this here is inside the loop. So you want to do the space that's inside the loop. And so when we do a flood fill, it'll flood fill here, it'll come across here. I think a flood fill solution will work, and we want to we'll end up with this shape, and if we flood fill like in the center, so we check the things to the left and right, we could still come in here and fill up this space. So these are the flood fill will happen here from the outside, and then everything on the inside we will get. So we just need like a mapping that does this. So I think we can do a flood fill on the outside if we do something kind of clever, where we're able to do in between spaces. I think we can do a flood fill in between spaces. We just need to do we kind of need a mapping. If we take our input, hang on, I think we can do something clever. Here. Let me play around with this real quick. This is our map. If we put a space between all of these, hang on. We want to do the space between. We can do it this way first. So notice I can now do a flood fill from the outside. Because I have a space, there's a character between all of these. I need to somehow translate this. We fill this in. Yeah. So my map, I might not even have to do a thing where I take half points. If I could come on, make those spaces. Just insert work here. If I am able to translate my map to this. Hang on. Yeah. Translate my map to this. If I translate my map to this, I can do a cheeky flood fill. At the end of the day, these would still be dots. These would still be dots. These are still dots. All right, so if this is my starting map, and I expand it out like this, and I do a flood fill here where I don't get stopped by blank spaces. Yeah. I don't get stopped by blank spaces. And when I encounter a Smap says that will work. It did for me. We do a flood fill where we translate these to outside. All right. So we're gonna do a flood. All right, we're gonna add in a bunch of blank rows and blank columns. All right, we can do flood fill. Insert caps O. So we'll flood fill the outside like this. Don't try and go into. It's trying to go in HLS. We're gonna. Oh my! Turn off. Undo. We're gonna flood fill the outside like this. We'll start in the top left corner and we'll flood fill, and it should come through, and really it's gonna fill in all O's if we're blank, and then we block on anything that's not a blank or a dot, and then we count our dots. We count our dots. We go through the input and say, okay, find the dots. Okay, I have a solution. I don't have to do midpoints, but I can separate it out here. I think I have a solution here. It thinks we're in Haskell mode, text mode, mode, text. Okay, so we're gonna do that, and this should fill in. All right, this is dumb, but we're gonna do it. It's dumb, but we're gonna do it. Okay, so we still need our maze because we need to clear out all the garbage. We need to clear out all the garbage. Keep in mind that we can have extra garbage tiles lying around. So we're gonna parse in our maze, we're gonna walk the maze, and then we're gonna get a new maze output. We're gonna new maze output that is expanded here. So we're gonna do public string array public let me think about this. We're gonna have our string array. I want to get back a new output that looks like this but expanded out. So I think I want it to be a string array. I might be an IEnumerable. Oh, my overtype is still on. IEnumerable of string. Expand map. I'm gonna expand the map here. And to do it, we need to first walk the map. So we're gonna get our dictionary of position, long distances. So this, if you're inside of this map, that means that you're part of the loop. You're part of the loop. And so we're gonna first start by clearing out the map. So we're gonna build up a new, we're gonna filter out all, so dictionary, position, really, this is, can make this a hash set, I think. Hash set. Pipes in maze. So this is like loop. This is our loop. Walk dot keys. Walk dot keys. Hang on. Do I only? I got to make sure I'm not doing anything really dumb here. We can print it out. We can print it out. Walk dot keys dot and we can use the new syntax, I think. Does this work for hash sets? It does. Okay. So this is, we're gonna walk it and then say, what are the keys that are in here? These are the positions next to us. So if we contain it, because neighbor only gets us things that are in our map, this should clear out the garbage. This should clear out the garbage. And now I'm going to I need to take our input. I need to convert it back to this string. Need to convert it back to this string here. And so I'm going to say, if I know my min and max positions here, let's create a thing here called int rows, int columns. So I want to know how many rows and columns this whole thing has. And so down here, The number of rows we have happens to be maze.length, and the number of columns is maze of 0.length. And if we had an input that was not rectangular, this would be an issue, but I think just make sure these all end at the same. Yeah, so our input makes this valid. Okay. So we have our rows and columns here. So now in our expand map, we can say for int row equals 0, row less than rows, row plus plus, for int col and it's 0, col less than cols, columns, col plus plus, string. I'm gonna do it as a string here. String array maze is equal to a new string array of rows. Okay, and then we're gonna build up the string inside. I feel dumb here. This feels messy. I think we're okay. We're gonna keep going here. We're gonna loop through our rows and our columns, and then I don't need this. I'm using an IEnumerable. Well, I'm going to because the messy captain. It's true. The messy captain. Okay. See if I can get it here with that one. So we are going to build it. It does feel quite messy. This is the wood hammer. This is the wood hammer method. It's true. It's true. Does the approach make sense? So I'm expanding it out here. And so I want to do a string builder. Builder equals new string builder. I'm going to pull this out to the top so I don't have to keep rebuilding it. When we start a new row, we'll do builder.clear like this, builder.clear, and we're going to do builder.append. In our maze, in our pipes, this is our loop. We're going to do pipes. If we just have the original input, it would be easier as well. I'm adding too many gross things here. String array raw. So right here we'll do rename this to raw. I'll do raw. Oh, I can't do that. All right, I need to make this a property I can get. Public, read only, doesn't matter. String array, raw, maze, public, raw maze, get private set. I don't like this either. Raw maze. I just want to be able to look up the original character. Why is this so hard? All right. String array raw maze. Okay. And then this just becomes maze. Right. I hate it. We'll refactor. Expand map. Did I break anything? Maybe, but give me some confidence that I didn't by running these. Make sure that my parsing and stuff didn't break from part 1 at least. Okay, so I still have a little bit of confidence that things are kind of working. I just spilt coffee. Give me a second here. This is why I usually use my fancy cup. My fancy cup has the Captain Coder. It's almost Captain Coder spill proof. I have a fancy mug that has like a nice lip on it that prevents me from moving. I'm moving too fast. That's what we call the wood hammer approach. I love it. Okay. So really we'll do builder.append. This would give us just the original map back. raw maze at row column. And then we're also going to append a space. Okay. So I suppose I could do this. Like that. So we're going to do the symbol and a space. And when we get to the end, we do builder.append line. Like this. So we add an extra space. And then, actually we would do yield return builder dot toString, and then yield return string add left. Total width is going to be our columns. So we can get an expand map here. It's going to return this. We haven't removed the things that are part of our walk here, but I want to write a little test here. A little test here on our simple input. Fact, public void test, expand map. Like this. And we're going to use our sample input. So we're going to do day 10 dot maze equals maze dot parse sample input. We'll expand it on our sample input simple. Fun fact topology, the statement that a closed curve like here even separates the plane into two parts, one interior of finite area and one exterior of non-trivial theorem. It's called the Jordan curve theorem. Today I learned TIL. Topologist, thank you for that, and for points. And topologist, 50 points. I like that. That is a fun fact. That is a fun fact. All right, so we're doing this one here. Thank you for the doi emote there. I love it. I love it. Okay. Sample input simple. Do maze.expand map. We can do a string dot join new lines on this. And the output should be let's do our expando. It's not easy to prove until you study complex number depth. We have, hang on, it was easier to add them all in this way first. Oh, I still have to add my walls in. It technically is going to add an extra line at the bottom, so I might trim string expanded equals. Okay. Right now my expanded should be doing this. String expected equals expanded dot should be expected, just so we can get a look at what it is. This might be something that just makes more sense to use a console program to test. If I'm looking at this being like a console program is going to be easier to just run this and test it, because this isn't really what I want. Should be but was beautiful. Look at, perfect. It's exactly what I wanted. I'm a little confused at that. I did something really, for every row and every column, oh. There we go. as returning the string every row. All right. Let's try again. All right, let's look though. Should be that, but was... The difference is insanity. Oh boy. They look the same. Do I need to... Oh, I am trimming. The difference... seems to be like silent new line characters or something, or that there's not the correct number of spaces. I think I might need to go here and print this out. I might need to actually, in my console program here, do something like this. Sample input. Like here. And we'll do console. I want to actually format this because my spaces are important. Console.WriteLine. McNets, how's it going? It's going all right. We did part 1, McNets. We are working on part 2. I think we have a winning strategy. We just have to make it work. Just have to make it work. Which I think should be okay. Honestly, I should probably be putting this into an array of cares. So I'm gonna have to do a flood fill on it. Thank you for the Doy McNets. How the heck have you been? How the heck are you doing? Console.WriteLine expected. Expanded. Can you guys tell I've been writing in Python by missing curly braces and doing weird stuff? Been writing in Python. So these really do look the same to me. My guess is that it would be more obvious, I suspect, if I use a special character to denote the extra space. I could also just put a dot in. Let's do a special character. I'm gonna do underscore. And this one, I think, can take in a character to pad with. If we run this. Yeah, for some reason, these aren't long enough. Why isn't columns the right size? Oh, times 2, maybe -1. There we go. Times 2 is what we needed. All right. Okay. So come over here and we'll do space, put the space back in. And I bet we might pass the test now. And the expand trick, this isn't all we need to do, expand. It's like the first thing we need to do. Expand map is still not matching. Still gonna be impossible. Still gonna be impossible. Maybe I make it a dot. If I just do dots, is that gonna be okay to do? I think doing just dot will actually be kind of okay to do. I need -1. -1. That's why I have an extra. And on the last one, if this is gross, if column is less than or equal, less than columns -1, builder.append dot. And then I think we have an extra line at the bottom as well. If we'll refactor rows -1. Expando. Still having an issue where I have an extra one. -2? That doesn't make sense to me, but that's okay. Oh, or does my expected actually have... Doing a right line there. Okay. Let's... Are we going to be okay if I just make them dots anyway? Let's make them dots anyway. Let's make them dots anyway. So when we expand, we just add dots in between everything rather than spaces. I think that is okay. 83 milliseconds part 1. Let's go part 2. Is it 80? How many milliseconds for part 2? If you don't mind me asking. So for now, I'm gonna put the dots in here. We're gonna fill those in just a moment. There's some. This is where I need to be using a char array because I need to be able to draw in a pipe based on what I'm seeing. But I just want to make sure my expand makes sense so far. As long as you don't leak. Yeah, I'm gonna try not to. I'm gonna try not to leak. Toak, is it 83 milliseconds for part 1 and part 2? You said 83 milliseconds part 1. Let's go part 2. And I was just trying to clarify. I don't know what the difference between these two things is. I'm assuming 5 milliseconds for part 1. Nice, man. Oh, you're starting part 2. Gotcha. I am confused. On the difference here. Lots of overhead to the clock. You're writing it in Unity. Are you planning to do a visualization? It does. All right, I am not gonna worry about this here. I'm gonna manually do this here because our expansion needs to do. I wanted to do this IEnumerable thing. We can still return IEnumerable. My implementation, I need to actually have an array.
Whoa.
Andy Lippy! Andy, how's it going, buddy? Thank you for the raid. What were you up to on your stream today? Thank you so much, folks. Attention all lurkers, we have a very important guest in the stream, Andy Lippy. Incredible streamer, does all kinds of awesome coding stuff. You often are doing OBS plugins, a lot of stuff. We got this. Thank you for all the follows on this raid as well. Andy, thank you for bringing your whole crew in here with you. Welcome aboard, everybody. Happy to have you here. If you're new here, I am Captain Coder. Captain Coder is me, and me is a computer science educator. I teach computer science and programming. It's my full-time job at a school for ages 10 to 14. So I work with young people, youth. It's my dream job. I absolutely love it, and it's so much fun. But Andy, what were you working on your stream? Today we are working on the Advent of Code. Day 10, we've done part 1. We're working on part 2. If you're not familiar with what the Advent of Code is a small calendar of 25 days in December. Every year, Eric Wassel puts together a bunch of puzzles for us as a wonderful Christmas present. You're working on your new Synamic Stream Island widget. Very cool. Very cool. Do you got any links for us? I think you should probably already be able to post links, but just in case you're not, feel free to send them here. You better than you think. You are better than you think asked what language. Today I'm working in C#. It's a language that I really like. It's not my favorite language, but I really like C#. I'm trying to get better at it. It is the language I use for many of my classes. Specifically my intro to programming class, I start with C#. We do a bunch of other languages too, but we're working in C# today. My students learn Lua and Python and JavaScript and Haskell, and we do a little bit of TypeScript. We do Python sometimes. I have taught in Python, but usually my students already know C# by the time we're doing Python. Not always, but usually. Lurkern, Gerg, YG, and Chaz, thank you so much for the follow. Lurkern followed me, and so did YG, Gerg. Chaz, Focus, thank you so much for following me today. Thank you. Thank you guys so much for the follow. I appreciate you so much. Andy says, I have no links at the moment as it's all just stream work. It's basically like Apple's Dynamic Island, but for a bunch of stream languages. That sounds super cool. Dogfish, welcome aboard to the stream, my friend. Happy to have you here. You're better than you think. Thank you so much. And Chaz, thank you. No, thank you. Thank you for being here, folks. Thank you. I appreciate you guys so much. Just to give you an idea of what we're doing right now, we are working on day 10 Advent of Code. And this is not the input I wanted to look at. It's this one here. Let's create a new one as well. We have a puzzle where we're given an input that looks like, let me go with the smaller one here. We're given an input that looks, well, this is a good example. We're given an input that looks like this. Come on, I can copy. I believe in me. We're given an input that looks like this. And our goal is to identify, you can think of these as pipes. There's a pipe that runs around in here. And the pipe is separating two parts. We have an outside part and an inside part here. And we're trying to determine the number of spaces that are on the inside of this pipe. You'll notice here, is considered outside of the pipe because it loops around here. So these positions in the middle are actually inside. And so what we've done here is we're gonna do, I would like to be able to do a flood fill where we start on the outside and we just search around and we fill in all the spaces saying that these are on the outside. These are on the outside like this. So we just fill in all the spaces. So we have all these marked as O's. But we run into an issue if our input, we can't just do a somewhat naive approach. If our input looks like this is still considered on the outside of the pipe because there's technically space between these pipes. They're not connected here. It sort of loops around. And so I have a strategy here. If you don't want any spoilers here for my strategy, tune away now. But my strategy here is to take our input, expand it in this way. Let's change language mode, this is text. And then we're gonna expand it this way as well. We are going to fill in the pipes here. So we're gonna increase the size here, like this. We're gonna fill in all the pipes and we end up with something that looks like this. So we expand it out, we draw in the missing pipes here. Then we do a flood fill on the outside like this, and then we're gonna count all of the spaces that we didn't hit with the flood fill. So that's my strategy here. I think we have a winning strategy. It's just a matter of implementing it now. But Viper Dogfish, what a great name. Have you met the Viper Dogfish? Yeah, they have followed me today. You know we got a Viper Dogfish. It's like a snake and a canine and a fish, all mixed into one. Thank you so much for the follow. I appreciate you being here, my friend. But yeah, that's what we're working on today. So we're working on our expand right now. So we're taking this input, we're gonna expand it out. And really when I expand it out, I want to add in all dots here on the outside. When we get to an S or a bar, this sort of thing, we need to add in the adjacent pipes. We need to add in the adjacent pipes here. And so we have this thing that expands it right now, but it does it in a kind of dumb way. I really need to do the following. It says care. I'm doing all right, G. I'm doing all right. I have a winning strategy for part 2. I think I have a win. I say I have a winning strategy. I think I have a winning strategy for part 2. I'm just trying to implement it now. And so I'm expanding my map out like this so I can do a flood fill on it. When we get to a pipe, we need to do some extra work on that pipe. What I could do, hang on, I have an idea. I'm gonna do a care array. I'm gonna do a jagged care array. I could do a multi-dimensional array, but I think it's gonna be easier to convert these to a string if I do it like this. I'm gonna call this my maze is equal to a new care of rows and columns. Rows and columns times 2. I can't do that, can I? Now I need to do like this because it's jagged. All right, let me try something here. Columns times 2. It's a little tricky. I have a working I think I have a working strategy. Kabatra daytime was actually something I could visualize how to solve in my head after a few tries and experience both parts, unlike the very cursed 8 part 2. Might have got a bit overrated with drawing out the state as an image. Gotcha. I think I have a strategy that'll work here. I just have to get the implementation. Kabadratisk, welcome back to the stream. I'm happy to hear you were able to solve yours. But yeah, we're going through our rows and our columns. Hang on. Can I actually be this lazy? Can I be this lazy? I want to do this. I want to be lazy. I need to be able to modify our in-betweens. Instead of doing a builder dot returning a yield here. Maze of row is equal to care array. Okay. I can do this. I don't actually care about that. I'm not trying to write this test and get it perfect. The flood fill can be on the new start. Very visual. Yeah, I think it'd be really cool to do a visualization. I'm really excited to look at the visualizations on the Advent of Code subreddit when I get a solution here. And then maze of row times 2 plus 1. Is that right? Dot 2 char array. Let me think about this. 0 times 2 is 0 plus 1. This will be the row 1 here. 1 times 2 plus 1 will be third. Yeah, I think this is correct. And then at the end, I need to do this dumb thing now, since I'm still doing an enumerable. Or I have blank space. Oh, I didn't like that. All right. Trim trailing white space. I ended up doing I visualized it this way. All right, so now my expansion, I'm gonna do for each char array row in maze. Yield return new string. We can do string of row like that. I think I can do this. All right, let's do a run here. You gonna blow up on me? There we go. Not quite. My expansion didn't do the thing that I wanted. It looks like we did columns correctly, but rows incorrectly. Rows times 2. There we go. There we go. All right, we have this expansion. I don't actually care about going too far. The next thing I need to do is I need to add in extra pipes. And so for every position in our loop, it's very ugly for part 2. I've heard very few people have a really nice, very pretty solution for part 2. So for every position, pipe in loop. So we know all the positions that are in our loop. We need to look up the type of pipe it is, and then depending on that type of pipe, we need to modify our maze. We need to add pipes into it. So we know that pipe type is our pipes of pipe. This will give us back the type it is. And then we can add in an extra symbol on each of the out directions for it. Netherman41, welcome to the stream. It's going wonderfully well today. We've got part 1 complete. We are working on part 2 of Advent of Code. How the heck are you, my friend? Are you familiar with Advent of Code? Do you know what today's puzzle is? If you want an explanation, let me know. I'm happy to talk through it. But basically, we want to do the following. Oh, do I even need the pipe type? I might not even need the pipe type. I might be able to do the following, because we have our raw maze. And pipe.row, pipe.column. This might be better. Character ch is this. So we have this here, and we can actually took you a little bit to debug part 2 in C++. Shouldn't C# shouldn't really be easier? Yeah, probably not. I'm hoping I don't have to do too much debugging. I'm hoping I can kind of just get my idea right the first time. That's sort of what I'm hoping. I can get my idea correct the first time. This probably returning the char array here is probably smarter, if I'm being completely honest, but this is what we're doing for now. But my strategy is to do a flood fill, Netherman. My strategy to do a flood fill, I'm going to expand everything. Yeah, exactly. I'm just going to go ahead and say, give me my symbol, and I do if ch dot pipes up, we're just going to add a symbol in the spot above it. So in our maze now, we're going to do pipe.row times 2. And then we need to go up, so -1, and then our pipe dot column times 2. And we're just gonna say this is like an extra symbol. This is gonna be our extras. This will definitely not take less than a second. Too much string manipulation. If it's, we'll see. It's all inside of an array though. It's all inside of an array. So it's not like I'm rebuilding the string over and over. I think we could optimize it as well. Yeah, I turned it into a char array because I didn't want to have to do replaces on it. But we'll see. We'll see here. We'll say if ch.pipes left. Let's do down first. If it pipes up, if it pipes down. We're gonna go +1. If it pipes, and I'm really not liking, I'm not happy with the code clarity I have here is not good. We need to add in an extra layer on the left, it looks like, as well. So right here, this is gonna, warning, does not account for edge of maze. I think we need to pad the maze. The easiest thing for me to do, I think, is gonna pad the maze one. Because if we're on the edge of the maze and we try and go left, it's gonna blow up. That said, if we're on the edge of the maze, we shouldn't pipe left. We should never actually pipe left on the edge of the maze. Same with pipes right. So this might end up working for us. Let's see. Okay. So it just added stars. I didn't have to actually I didn't have to do anything special. I'm just gonna say a star is a special symbol that we ignore. I always go for the double array. So Smab, the reason I didn't is because I wanted to build this string up here easily. That's the only, I agree. The only reason I didn't do that was because string doesn't take in, unless there's a nice way to get a row of chars. But really, at the end of the day, I'm just going to return the char array here, I think. Now that I have this expansion, I can just do a flood fill on this array. And then this is why I didn't want to have the dots. I need a special symbol for my expand. All right, this is why I didn't want dots. These should be spaces. Because at the end, I want to just find all the leftover dots in my string. I want to find all the leftover dots in my string. I'm going to do a flood fill. My flood fill will go and basically rewrite everything in here. Exactly. So if you want to see what I'm doing here, it's this. I want to do a flood fill. WizQuicks, welcome to the stream, my friend. Happy to have you. Yeah, we're doing the Andy right. Thank you for the doi symbol. So I was like, I know I can do a flood fill here. So all I did was I'm going to take my input and expand it like this. Fill in the gaps so I know which direction all my things are going. So now I have this new input here. Now I can just do a flood fill on this solution and then count the leftover dots. So that's the solution I'm coming up with here. Expand map is return an IEnumerable of strings, which I just did this to be able to print it out nicely for a sanity check. And really, I just want to return the array here in that regard. Whiz Quicks, thank you for the follow. Whiz Quicks followed me, and I want to say thank you to the Whiz Quicks for following me. Thank you, my friend, so much. Smab, I've done that before, and that's probably what I should do. Thank you for the follow, Whiz Quicks. I hope you enjoy your stay. I'm glad you're here with us on this beautiful day. Yeah, so Woosa, welcome back to the stream as well. Happy to have you here. Thank you for the dancing coffee mugs. Thank you for the dancing coffee mugs. I appreciate them. This should not... The expand map shouldn't return a string like this. It really... Like Smab is saying, it should really be an array. Jenna Mays, you'll see later. Nice to meet you, WizQuick. Welcome to chat. We are working on Advent of Code. I'm going to... Let's do an expand on... I just want to make sure we don't throw an exception here. Test expand map on our input. Puzzle input. I want to just do an expand and make sure that we don't crash. I just want to make sure we don't crash here. And I want to look at the... all right, test expand map does not crash. This is a dumb test, but that's what we're going to do. .NET test. .NET, let's see. .NET test. Let's run them. And with a 2D array, because it's easier to modify with in Python, but I'm not sure it also is in C#. It would be just as easy to modify. All right, so we don't crash. That's all I really cared about there. All right, let's do a flood fill. Let's do a flood fill here, and I think I'm just gonna make this separate. Public static void flood fill. It's gonna take in a character array. Maze like this. Maybe I'll put it, maybe I'll do it down here inside of my maze. This code is getting gnarly. The reason I want to do a flood fill separate is because it's not actually related to what we're doing here. You know what? I'm going to do it. I'm going to do it up here. Care maze, and then it's going to modify this whole thing like this. G says, also, you are currently still having camel cards in your stream tags. Oh, interesting. Thank you for that. Look, I don't know how to stream. I ain't no professional streamer here. This is amateur hour. I can't say that I'm new to streaming anymore, unfortunately, which is what I really want to be able to say, but I can't. So we're gonna take our maze. We're gonna end up with our I'm gonna be lazy. Should I be lazy? I want to be lazy. I want to be so lazy, but it hurts me sometimes to be lazy. Maze.expand map. String.join on our new lines here. String, hang on. 4 each. Why does it hurt? 4 each. All right, 4 int row equals 0. Row is less than maze dot rows times 2 plus 1. Row plus plus. Should have just done this. Yeah, I already have to do it. Smab, I have to do this now. All right, we're gonna do this. We're gonna do this because it'll be easier. It'll be easier, right? Am I right? Maybe not. Maze dot expand dot select row goes to row dot to char array. Look how dumb I am. Look how dumb I am. We are going from a char array to a string back to a char array. Don't be too mad. Oh my gosh. All right, to a char array, and then this is gonna be our. Why do you think functions, abstractions were invented exactly? Char array, to fill. I do this. All right. There we go. There we go. This is our maze here. And then we're gonna do a flood fill on to fill, and then I want to count all of the dots inside of it. I want to count all of the dots. So now it's gonna be to fill dot select row goes to row dot new string row, and then we're gonna join string string dot join. This is, it doesn't matter. We just need to loop through all of them and pull out all of the dot row dot where column is a dot sum row. Could never get used to the reference types in C#. Yeah. Here, long count equals 0 for each. I don't know why I can't write it this way. Each char array row into fill. For each char ch in row. If ch is a dot, count plus plus. This is what I want. Return count. And this should return a long. Okay. What is the input in this program? Sinfire, great question. Great question. And Sally the Goose, welcome to the stream. I'm doing this one in OCaml, and it is so hard. So hard. If you don't want any spoilers, Sally, I'm gonna talk through my solution or my attempt here in just a moment. Our input looks like this. So it's a maze. Our input looks something like this, Sinfire. And we are calculating, I'm gonna do a flood fill. We're calculating the number of dots that are on the inside of this pipe loop. So this is a pipe loop. Gotcha, doing it in the functional programming paradigm. Gotcha. Yeah, I am doing some modifications, but our puzzle input's much bigger. The actual input is this. The actual input is this one here, Sinfire. So it's a little bit spicier. The input's a little spicier than that small one there. But yeah, that's what we have. And so we're gonna do our flood fill and we're gonna count it here. It's a text file, yeah. And so now, I'm gonna look at my inputs. What I really care about, I need to put, all right. I need to do a wrap around the edge to make this a little bit easier. So I want to add a row at the beginning of my input and a column on each side and a row at the bottom of my input. So I need to pad my input here. Le Pew 3D, welcome to the stream. Le Pew. Oh, Le Pew. Thank you for following me today. We got Le Pew. Oh, Le Pew. Welcome to my stream. You are here today, and I gotta say, thank you for following. I hope you enjoy your stay at Captain Coder's Academy. Welcome to the stream, my friend. Happy to have you here. Yeah, I want to pad this so that it can guarantee that if I do a flood fill from the top left corner, that it won't be an issue. Is each line in the text file a row, or is the challenge to determine the number of rows and columns based on the maze? Each input is a row in a two-dimensional grid. Each input is a row in a two-dimensional grid. So I need to, in my expand, I want to pad another option would be to pad my input here. Input equals input dot pad grid, something like this. This might be a reasonable function to have. What do people think? I know I'm getting really inefficient here by doing stuff like this. But I'm gonna do a pad grid 1 where we add in just a pad grid like that. Good vibes. Welcome back to the stream. How you doing, Ben? Welcome to the stream. Happy to have you back. I'm gonna write just an extension here. Public static. All the string manipulation certainly is gonna slow things down. Pad grid. String input. This string input. What if the days that end in 5 have tougher problems than the other ones? Maybe. That might be the pattern. I don't think there's actually a pattern. But that's a funny idea. Input dot split on our new lines here. And we're going to say, just finished part 2 in C++. It's kind of wild. I have a working strategy for part 2, Zorik. I keep saying I have a working strategy. I think I have a working strategy for part 2. String builder, SB equals new. I just got to do it. I'm going to do a flood fill. Is regex in JS the same as regex in C#? I'm currently learning it in JS. That's a good question. Regex JS versus C#. Difference between C# and regular expressions here. It looks like they might have slightly different ones. They're going to be mostly the same, it sounds like. If you learn it in one, you will have it'll be good for both of them. So the first thing we'll do, string rows equals this, sb dot append. We're going to append we're going to put a pad grid char symbol. We're going to append pad with our symbol here. We're going to pad with our symbol. And it's going to be rows of 0.length plus 2. So it's going to put a row on both ends. At the very end, we need to do this as well. We're going to do append line for each row, string row in rows. And we're going to say int width is going to be equal to this width. Like that. Freedom Dow. Welcome back to the stream, and Maxwell. It's nice to see you again, my friend. I'm glad you're here with us. All right, so we're going to pad our line here, and then we're just going to do sb.append line row.pad. Well, we have to add one on the left and one on the right, which is... All right. Like that. So we're going to pad one on the left, one on the right, and really it's just our symbol. Just like that. Just like that, yeah, all the code, all the lines. Then we're gonna append this here, and then we're gonna return as b.toString, like that. So this should pad it. Technically, if we did this, all right, so this should pad our grid. I just want to make sure this makes sense here. Console.writeLine sample input.pad grid. Pad it with a star. .NET run. .NET. So I gotta go to my implementation. And then we'll return. You are better than you think. What's going on? The argument given does not correspond. Pad grid. Okay. Part 2, we're gonna pad with a dot in this case. I'm close. Why? Well, let's take a look. My output. One more time. My output length +1. It's length +1. I don't understand why I don't get the extra symbol on the end. It's very weird to me that I'm not getting the extra symbol on the right side. That feels very strange to me. That feels really weird. What is that? I thought it should be +2, but it's not. And it might just be how the pad works. Total width. Yeah, I feel like it should be +2, but the padding's doing something weird here. JS meet. JS meet. I would like to say thank you for following me today. JS meet. Thank you so much for the follow. If I'm pronouncing that wrong, feel free to correct me, but welcome to the stream. It might just be JSM, but happy to have you here, JS meet. What am I doing wrong here? Steve, we got part 1. I think we have a winning strategy for part 2. We're in the process of implementing. We're gonna do a flood fill. Yeah, that doesn't make sense to me. Steve, yeah, I look forward to seeing your 1 microsecond solution. It's true. It's true. What is up? Why? Help. I'm so confused right now. SB.append. Help. SB.append row. SB.append. Help. New line. I am so... Oh, Kasao, I'm on Windows, and Windows is the worst. Windows are the worst. Kasahu points, and I was about to lose my mind. 5, that's gonna save me so much time. 700 points to you, my friend. Thank you so much for saving me there. I'm sure that was what's going on. Okay. Help. This was not making any sense to me. Replace line endings every time. Yeah, Smab, maybe someday I'll learn. Someday I'll learn. Okay, now we can do an append line. Whew. Yeah, okay, so it is linked +1. All right, we're gonna append that there. So now in our solution, we're guaranteed that we have a pad around the whole exterior here. So in our input for part 2, whenever you need it, yeah, replace line endings. That's what I should do. That's cool. I didn't even know there was a replace line endings. Replace line endings. And I can just do new line. Is that what we're saying we can do here? Let's go back to CRLF. Nice. Nice. But you're suggesting I use like the environment new line, which is probably the smart thing to do. The problem is I now have to change all my code that does the split in other spots, which I suppose isn't too bad. So here, instead, I would do environment dot new line. The problem is that in my... Not the problem. Now I gotta go change other code. Nope, that doesn't work. Oh, because I've done this. I don't know why. I'm gonna go back. I don't want to waste any time right now. I'm not interested in this right now. I think it is a good idea to do this. Source Drift. What a cool name, Source Drift. Drifting about, we got a source drifter in our midst. They're drifting the source, and it's so cool. It's like Need for Speed, but you're writing code. Source Drift, thank you so much for the follow. Welcome to the stream, my friend. Happy to have you here. Let me make sure I didn't break any of my tests here. I did something terrible. Mizzard X, that's probably a good idea too. I'm gonna wait to do that because I'm okay with where I'm at right now. And I will try and be. I'm just trying to get done with this. I'm trying to finish this up. Science, welcome back to the stream, my friend. How the heck are you doing? I know, I'm so close. I just got to do this flood fill, and then we got it. So I'm trying to keep going here. I'm trying not to get too distracted. Science says, doing okay. How are you, kind sir? I am wonderful. I am great. I'm having a beautiful morning today because of you, Balint. I'm glad you're doing well, my friend. Scally Games raided me in, but first we gotta sing Nineberry a song. Nineberry, thank you so much for the follow. Nineberry following me. We've got Nineberry following me. Nineberry's better than 8. Nineberry, thank you so much for the follow. I appreciate you. And also Scally Games Dev. Scally Games Dev, thank you for raiding into me right now. I just wanna say, Scally, thank you for rating me today, cause you know you're great, and I hope things went super well for your stream today. So Scally, tell us, how the heck have you been? Scally, thank you so much for the raid. Folks, if you guys are not following Scally Games Dev, be sure to give him a follow. Scally, thank you so much for the raid. folks. Click that little heart. Give them some love. Scally, what were you doing? Things went horribly. You were working. Were you doing admin of code yourself? We got part 1 done, Scally Game Devs. Scally Games Dev. I like that name. We have done part 1. We did a breadth first search, which turns out is overkill. We don't need to do a breadth first search, it turns out, but I did a breadth first search to find it. Part 2, I think I have a winning strategy. We're going to do a flood fill here. I just haven't done it, but I think we have a winning strategy for our flood fill. If you don't want any spoilers, let me know, because I'm about to talk about my solution here, or my strategy. I haven't quite solved it yet. Taco Slurpee. Oh, that sounds delicious. Taco Slurpee. Have you had a Taco Slurpee? Someone asked me this Sunday, have you drink a Taco Slurpee? It's so thick and good and greasy and delish. Taco Slurpee, what a name. Thank you so much for the follow. Welcome to the stream, my friend. It should have been very easy, but it took me way longer than it should have. Nice board game collection. Yeah, we got a few. We got a few board games back there. Just a couple there. I can't quite fit them all on my wall, but we got a couple board games on that back wall there. This new shelf, I just moved into this office 2 weeks ago. This new shelf I thought was gonna be big enough for all my games. It's not big enough. I don't have enough room. Yeah, I got quite a collection of D&D books over there. Pretty awesome. Scally Games Dev, thank you so much for follow. Scally Games Dev, thank you for following me today. Scally's Game Dev, thank you so much for follow. Yeah, if you have any links to any of the stuff that you've been working on, feel free to drop a link for us. But we are just trying to finish up our solution here. We're gonna do a flood fill. We're so close. We're so close here. We're gonna do a flood fill. I've expanded out my input. All right, so if we have this as our input, we expand it out to look like this. All right, so let me just show you here. The trick is to add more shelves in. So Steve, I have a plan. You see, I don't have my step ladder in here. You see all that space? You see all that space from here to the ceiling? I'm gonna get some little mini shelves, so that way I have a little bit more room going up there. But I think we might be able to get them in there. No worries, Scally. That's okay. But we have too much wasted space. That's right. The trick add more shelves toward the camera. Yeah, so we got layers. We gotta be able to have a maze that we walk through here. And let's come back to our desktop. All right. Oh, I was gonna show you, we're expanding our grid out here. We're gonna expand our grid out so that way we take our input and it gets expanded to this. This becomes our expansion. And then we're gonna do a flood fill on it. And then we're gonna count the dots on the inside. Is it Scally or Scaly? As in Dragonborn. Oh, I could have it right. It could be Scaly. All right, I gotta actually do a flood fill here. Flood fill. Oh, flood fill. I gotta do you right now. Okay, so we're gonna say flood fill. Int row, int column. All right. And we're gonna do a flood fill at the top left here. Flood fill at the top left. And then we're just gonna go each direction here. We're gonna say maze at row and column becomes O. Then we are gonna say go in each direction. If go. All right, we have different directions. We gotta go. Position. Position dot row. Position dot column. And this is going to be our new, we'll do this at 0, 0. Okay. Next positions. If position.row, I don't need this, hang on. I'm slowing down, folks. I'm slowing down here, 0, 0. We don't need this. Int row, int column. If row is less than 0, or row is greater than maze of maze.length, or row column is less than 0, or column is greater than equal to maze of row.length, then we return. This says if we're outside the bounds of the maze, stop. 9berry, 1 second. Permit 9berry. Feel free to share it there, my friend. Thank you so much. Seed developer prog. I never used flood fill algorithm. Interesting application of the algorithm. Yeah, we're gonna do a flood fill on it. Flood fill is a variation of breadth first search. But you're not doing a search, you're just filling up the space. There's no exit that you find. You just go as long as there's more space. And we're gonna do row and column here. We're gonna fill it in. And then we're gonna say flood fill row column. This isn't quite right. Row plus 1. We need to go each direction. There's a couple more times we have to stop. Why doesn't it like this? I have to pass in my maze again. All right. Maze row -1. We go in our cardinal directions here. All right. There's one more thing here where we are going to say we're inside of our maze. We're going to say maze row column. If maze row column basically, if it is a dot or... All right, so the two symbols that we care about are dot and space. Dot contains... if it doesn't contain these, we also return. If this is a wall or we've been here... if this is not a flood fillable space, exit. All right, so we only you did flood fill for yours too. Cool. I made the flood fill argument in a kind of weird way. A 2D array, all border tiles, if empty, were made marker tiles. Yeah, so I pad mine. I'm gonna start in the top left, and I'm padding it with a dot. But when I expand, I get spaces, I believe. Yeah, my expansion has spaces. So I could put any symbol here, which is fine. But I think this will do a flood fill. I think this will do a flood fill here. We'll find out. One of your solutions is flood fill? Nice. I'm not happy with how disgusting my code looks. I will say that. I'm not happy with how disgusting my code looks. I probably need to go back. I would love to go back and refactor it. Something went wrong. Of course. Something went wrong. We got back 1. Sample input part 2. Here are just the tile. Is it because I have that? Disgusting code for AOC, I would never. But it was fun. Didn't end up as beautiful code, but it was fun, Steve. I'd love to check it out. We're so close. We're so close. I don't think this is actually going to pass. I think there's something else in here. I need to, I think, look at my output. Still one. This might not be running it through this, though. We need to take a break here in just a moment as well. I want this. I want to finish this before I go on break. We've been going for a while. 2fill00. Let me print out my flood. I feel like you could have spent more time jumping into the wood hammer solution. I could have topologist my look. I have a one-track brain. I couldn't help myself. I just had to. Yeah. It says Krasenstein chatted, but I don't see your chat. Krasenstein, I'm sorry I missed your chat. Welcome back. Oh, hey man, how's everything going? It's going beautifully well. Krasenstein, welcome back to the stream. How have you been? You still working on Worlds of Grimm? I'm sure you are. Worlds of Grimm. Folks, be sure to give Krasenstein a follow if you want to watch someone, a game dev, creating a game called Worlds of Grimm. Be sure to check it out. At least we're not trying, yeah, CRT. No remainder theorem today. No remainder theorem. Let's in our program do flood fill. Let's in our program do flood fill here. Just to see what the heck is going on. Am I testing the wrong input? Sample input part 2. Okay, I'm not testing the wrong input. Let me come over here. My program. We're gonna parse our sample input and simple. We're gonna expand it. Let's not join these. Let's do what we're doing for part 2 here. That's what I'm doing for part 2. I guess I could do, I want to print out console.writeLine. Okay, I want to go through, I want to join up. Yeah, Nineberry, I expand it like this. So my flood fill will work. I expand it like this. So flood fill work. My initial thought was I need to do half pixels, but when I was playing around with, I was talking through it, and this ended up working out for me. Popcorn, welcome back to the stream. I hope you're doing well. How's it going, buddy? It's nice to see you. So my flood fill, I do a little bit more for my flood fill. It's not just a straight flood fill. I was gonna do a flood fill on half positions. And then when I was playing around with this ASCII input file, I discovered that I could do this. I kind of discovered this by accident while we're playing around it. I woke up to a stocked fridge. I'm glad you have a full fridge. I abandoned flood fill for my solution, Alka says. I'm hoping I don't have to abandon it. I think my flood fill here is my brain is tired. I'm trying to have I expanded. I want to turn this into, let's not join this. All right, I'm ignoring chat. Because I have to focus. Just for now. Because I need to select these into a expanded map, returning an enumerable of strings here. This needs to do this. Maze.expand. So we have our 2 fill here, and then I want to do maze dot To fill, how do I access this? Flood fill, maze, is this input? It's day 10.floodfill. Day 10.floodfill to fill. Start at 0, 0. Okay. Start at 0, 0. And this should modify this one. And then we're gonna do to fill dot select. We're gonna convert our rows into strings. New string of row. And then I want to do a string.join new lines. So I want to see, when I do my flood fill, what is the output that I get at the end of this? So I had to, sorry about that. I want to see here. Am I returning early? It did nothing. It did nothing. My flood fill did nothing. Let's take a look. Let's take a look. It's in a book, Reading Rainbow. Run, start debugging. Exactly, Scally. Sorry, I never checked. Is it Scally or Scaly? But yeah, I'm doing a flood fill, and then I'm saying, give me the remaining dots on the inside. All right, so flood fill. Let's step into flood fill. Am I just returning immediately? No. Why is it not? I should get at least one O in the top left corner. This is crazy. C developer, that's exactly right. I kind of stumbled into this solution when I was thinking about doing a flood fill between the lines. I stumbled into it. So if you expand it, you can do a flood fill and it should work. Chat's moving by so fast, I'm missing stuff, so I apologize. I'm really trying to focus here. I don't understand. Hang on. To fill. Oh, I didn't do a console.writeLine. All right, this is just my padded grid. String result equals console.writeLine result. This should be called filled. Filled. I gotta focus. So that one is okay. That one is okay. All right, so my flood fill is doing a thing. On our sample input, am I not removing the garbage? Is that what's happening? Maze.parse, expand map. Am I not removing the garbage? When I expand the map, I don't remove the garbage. Okay. All right, I'm not removing the garbage. I'm leaving the garbage in. So give me a second. Yeah, I left the garbage in. We don't want garbage. So I want to do this. Here. So my maze had garbage left over. We're going to replace the garbage with a dot. And then we go through all of our pipes here. And in our maze at pipe.row times 2, pipe column times 2. This is the original symbol. We only keep our original pipes. Let's make sure this still runs. Let's do our test. Let's do our test here. It's permit. You have a space in Bumpo there. So permit Nathaniel Bumpo. There you go. You typed in a number. You just no number at the end. It just automatically gives it to him. All right. There we go. All right. Our test input's passing. We might have a solution, people. We might have a solution. We might have a solution. Puzzle input. Test. Puzzle input. Come on, fill the noise. Give me the solution. All right, here we go. And then we gotta take a break. Then we're gonna take a quick break. All right, so it didn't crash. We got 523. We didn't need a long. Hey! We got it. We got it. King, welcome back. Yes, it is the 10th. This is a family-friendly stream, my friend. So no worries, no worries. It's PG-11 teen, so PG-13 language. I know most people don't mind. I'm a little finicky. I teach students ages 10 to 14, so I try and steer away from a little bit of profanity there. But don't worry about it. Don't worry about it. It doesn't bother me. I just don't want it to show up on the stream later. All right, folks, we done did it. Thank you for the stars, Smab. All right. Boy, oh boy, was this solution disgusting. Look at this, my code is nasty. Get status. All right, let's do a commit here. Git add, git commit, chore or feat, implement day 10 part 2. We done did it, folks. We done did it. Whew. Who would willing expose himself to Twitch chat? It's true, Cabadris. It's true. Also, thank you so much for the follow, C Developer Prague. C Developer, thank you for following. Welcome to the stream. Thank you so much for the follow. I appreciate you being here, folks. We done did it. We got our second part in. Hillenberg. Thank you for following me today. We've got Hillenberg. Welcome to the family. Thank you for following, and I'll say thank you for being here on Sunday. Oh, Hillenberg. Thank you for following me. Yeah, absolutely. Everyone, if you want to share, exclamation point Q followed by your message. If you're new here, it might block you, but it'll add you to the, not block, it might remove your text, but it will add it to the questions queue here. So 1 second. All right. So if you do exclamation point Q followed by a link to your solution, we'll take a look at it, folks. It's more engaged, yeah. Okay. I need to take a break. We've been going a little bit longer than I normally do, but feel free to get it in there. If you're new to the stream, if you haven't been here long enough, you're gonna get a message saying that you can't in-queue it, but please do, please do. And I gotta take a break. We'll be back. I'm gonna get myself some tea, get myself some leaf water. I'm out of regular water. I gotta fill up my fresh water. When we come back, we're gonna get some stretches in. Then we're gonna look at your solutions. We're gonna take a look at your solutions. But when we come back, we're gonna stretch first. We gotta take care of ourselves. So get your family, get your friends, get your coworkers. Call your boss up. Boss, hey boss, it's Sunday. I know I don't have work today, but the captain's about to do some stretches. So get your butt over to the Captain's Academy so we can stretch together. All right, folks, I'll be back. Stay tuned. Installation. All right, everybody, we are back. Sorry that took so long. Had to get myself some tea. Had to get myself a little bit of tea here. I got myself some Earl Grey tea. It's a little bit too hot to drink right now. Normally we do stretches, but I got a limited bit of time. So I hope we had a little bit of stretch going on for you. We're gonna hop right into doing some of these code reviews. We got a lot of them because I have about 40 minutes, and then I gotta run. But I want to welcome Stu the Man. Stu the Man. Stu the Man. Thank you for following me today. Oh, Stu the Man. I wanna say thank you so much today. Thank you so much today for being here. I appreciate you. All right, that one didn't go in for some reason, but I'll go ahead and copy that in here directly for you. Why didn't that one go in? Q. There we go. I don't know why that one didn't get queued in. Lanky Telephone, welcome to the stream. Welcome back. Happy to have you here. All right, if there's something in chat I missed, feel free to queue it up. We're gonna take a look at some people's here, some of these solutions. Smab, you want me to look at your gist solution here, or the one you have on GitHub? I'm assuming it's just outdated. Let me know if you want me to pull your repository. So you're sending a gist here, so I'm assuming you're not quite ready for that one. Let's take a look at Smabs here. Oh, you were just sending. Oh boy. Oh, cool. You were sending your maze thing here. That looks kind of cool. Kind of a scanline solution. This looks really cool. The gist is a diagram. Really cool of your expansion. Gotcha. Pull the repo. Gotcha. Here we go. All right, we're gonna take a look at Smabs here. Get Smab. Advent of code. Solutions 2023. We'll open this up here. Okay. Boom. Pull this off to the side a little bit. Look at some solutions over here. All right, git pull. And then my brain's not working today, folks. My brain's a little bit melty, a little bit mushy. All right, day 10. The word bend there I like. Starting position inside, outside. Nice little definitions here. Smab, your code always so production-esque. I feel like I would enjoy working on a project with you, Smab. I don't know that you'd enjoy working on a project with me, but I feel like I'd enjoy working on a project with you. All right, so these are our pipes, our bends, our straights. Here, the animal. That's it. Oh, you're trying to find the animal. What does your animal record type look like here? Kaka-san, welcome aboard. Thank you for following me today. Thank you for the follow, Kaka-san. The animal has this is our maze here. We're gonna do a move. It kind of looks like you're gonna take your animal and run it through the maze. All right, so this is sort of what mine was doing here, where we're saying when we have a bend, there's gonna be two directions we can go in it. And so it looks like we're gonna say what are the directions we can go there. All right, let's go back to our part 1. We have our animal and we move. All right. We have our animal run through the maze. This is cool. Move basically determines the pipe we were coming from, the pipe we we're going to, take a step. And because we know it's a loop, I wish I had thought of this. I missed it though. When you go through the maze, if you count the steps, we know it is a cycle. And therefore, if we take the maze and we take the number of steps and divide by 2, we get our answer. I really like this solution. So Smab starts at the beginning and then says, all right, calculate which direction I can move, take a step. And you just step all the way through the maze. All A really cool solution. Muhammad says, a 12-year-old boy from Egypt. I learned programming when I was 7 years old. Me too. I started with Python, then I learned C#, then I learned filters, then website program with HTML. Says, can you give me advice on how to continue? Because my dream is to study in America and work at Microsoft, then create my own company. You currently live in Dubai. That's amazing little story you got there. Personally, it sounds like you got some good progress. You're only 12 years old. That's incredible. I'm going to recommend to you to study C# Player's Guide. I think this is the best learning C# resource there is. It's going to teach you object-oriented programming as well. Do every exercise in this book, and you will be in a really good place. You'll be in a really good place. This book is awesome. Absolutely fabulous. Do every exercise in this book, and you're gonna level up so much. Kerp Derp, what a name. Kerp Derp, welcome aboard, welcome aboard, welcome aboard. Kerp Derp, welcome aboard, and thank you for following me. Kerp Derp, welcome to the stream. Happy to have you here. We're gonna come back to Smab's solution here. Part 1. I wish I was smart enough to think of this to step through the interior and then divide by 2. ThinkBot Labs, welcome to the stream. It's nice to have you here. I hope you're having a beautiful day. Good morning to you, my friend. All right, so solution for part 2. Solution for part 2. So Smab, your solution here is the same as mine. Is that correct? Create a bigger pipe maze. Yeah, I kind of stumbled along upon this accidentally as well because I wanted to do a flood fill. Divide and traverse both ways and find where they were equal distance. You could do that. Yeah. So if you travel both directions, and then when you end up at the same spot, you're there. So count the steps until you get to the matching spot. Just be a child. Yeah, Scally, that's exactly great advice as well. You're young enough, just build projects, have fun, do cool things, and you'll get there. I started programming when I was 7. I just enjoyed it so much. All right, so Smab is going to make his create a bigger pipe maze. I want to see how you do this. Yeah, look how much more beautiful this is. Smabs looks a lot more concise than mine. You have array helpers. Is this something that you've written? Or is this something? Yeah, Smab has an array helpers. Create 2D array with the number of columns times 3. Interesting. So your expansion I think your expansion is what I was initially thinking I would do, Smab, where you're wanting to calculate the center. This just pre-fills an array. Okay, sorry. Ignore me. Because my initial thought was to make every spot expand out. So if you have every spot, you can expand out and say, okay, well, what is the spaces adjacent to this one in 3 directions? And maybe that's what you do. Yeah, you go out. Oh, you're right. So you go out in every direction, orthogonal and horizontal. Targeting the center is easier. Smab, yeah. So you target the center. My initial thought was like, how can we do a flood fill on this doing half steps? And so this is what I was going to do with my initial one, but it wasn't going to be like a carry. I was going to do something crazy probably. But yours expands, you center and you say, okay, well, this thing needs to now take up a 3x3 space, and you build a 3x3. Every one expands 3x3. And we just basically translate it in there like that. Very cool. But you shrink yours down at the end. Okay, so we make a big. Let's look at your solution for part 2. Part 2, make a big maze, perform a flood fill, Flood fill pipe maze. Send pipe maze. Then return bigger pipe maze. We walk it. This is interesting here. I replace it with a 3x3 version of the 1x1, so it's a box-like diagram, and then you shrink it to be able to print it out. We have the bigger one, and then you sort of count. You have a translation to the smaller one. Okay, so then you shrink it back down. So you go to big, then you go to small, and then you walk the small one counting the cells. I really like the 3x3 expansion. My initial idea was to do a flood fill in between spots. My initial idea was do a flood fill in between spots, because I know we can go in between and like calculate like a 0.5. So instead of doing it on here, so yeah, I really like your solution a lot, Smab. That's really, really clever. The small one is just a print. Gotcha. You walk 2D array. I see that. Sorry, I'm dumb. Yeah, you're right. I see it now. It's just to print it out because it's huge. Yeah. If solution is solution method.polygon, are you doing? Okay, you can switch between two. You have a solution fill and polygon. Ooh. Let me ask. This is an interesting thought. Are you going to draw out a shape and then check for each position in the map if you're inside of a polygon? That's a really cool solution. That's a really cool solution. Trying to find a point inside of the polygon. I've heard of this algorithm. I've never done it. Point inside polygon. So you basically say, go through every point, check if you're inside the polygon, and then count those points. Nice. That's a really cool solution. That's a really cool solution. Point in polygon. So you build up a polygon, because we know because it's a loop, it's going to be a polygon that loops around the whole thing. Very cool, Alka. Yeah, we'll take a look at it here. Point in polygon. I wonder... I'm wondering if you could use C#'s built-in shape methods to do something like this as well. Min-max of each scan line. Gotcha. This is a really cool solution. So we have our polygon, and then you've implemented this algorithm here that checks if the polygon's inside. I'd probably just generate a PNG from it, export it, open it in MS Paint, flood fill in the in that, and then read the file back in. Popcorn, that's a cool idea as well. Smab, this is impressive. So yeah, I've never done this algorithm. I've heard of it. I don't really quite understand how it works. But point in polygon. Let's do a look. Point in polygon algorithm. So if people are interested in, this is a solution you can use. Because yeah, I'm wondering if we could actually just use a built-in shape. Let's see. Point, oops, I have the wrong tab. Point in polygon C#. Wondering if there's already... There's nothing quite built in. Ah, is this the one you... This looks an awful lot like yours, Smab. I believe this is the solution Smab has in his solution. All game players need to worry about it. Yeah, that's cool. That's cool. I like that. I like that. All right, let's take a look. Smab, for sharing your solution with us. Points, add Smab, 500 points. Thank you so much for sharing. We are gonna check out the next one here. Oh, I missed it. I'm dumb. That's why you linked it. Look. I was hired to code, not read. I can't read English. That's not code. That's an URL. That's an URL. But part way through, I realized how to do the flood fill. Gotcha. I really like it. I really like it. All right, let's take a look here at Nineberry. Nineberry. Readings for nerds. We don't do that. What do you think I am? Some kind of nerd? For part 2, I used a different, less mathy approach. While traveling the loops, I mark all cells to the right in the direction of the travel as inside, then flood fill to grow the areas marked inside. Interesting. Let's take a look. I'm going to pull this into a text editor here. Hopefully it'll detect C#. Zorik 13. Thank you for following me today. We've got Zorik 13. Welcome to the crew. Zorik 13, thank you for the follow, my friend. I appreciate you being here. We're in C# here. Let's take a look at Nineberry solution. Nineberry. Here's our program. Width, height, game map is an array. State map, string builders. Oh, that's a neat way to do it. Probably rather than using my char, the what I was doing with chars. These are the directions, northeast, south, and west. We have a point. I like that you're using a point structure. X and Y always makes me confused. That's why I use row and column. For me, it's confusing. All points here. We're gonna build this up. And you're just going to end up with a game map. I did a bunch of extra work converting mine into a graph data structure because I thought I had to do a breadth first search. So I did a bunch of extra work doing that. It's okay though. It's okay though. It's okay. Folks, I'm okay. It's going to be okay, I promise. Okay, let's keep going. Get our state map, state line here. It's always Y, X and never X, Y because it's always row and column. Gotcha. I would just name mine row and column because I get too confused if I don't. We go through, we add all of our points to an array. Part 1. We're going to find the steps and divide by 2. So let's take a look at yours, part 1 here. Find the start. Our last direction is none. Our current tile, forbidden direction. We get the opposite direction of our last direction. I'll open up a second thing here, just so I can come back more easily. The forbidden. All right, in our direction, none goes to none. Okay. So if we didn't have a previous direction, all right. I'm a nerd. We're all nerds here. I hope. Only nerds allowed. All right. So we keep for each for all of our possible directions. We go through. We do a move, and then we test it if we can move into that tile. Okay. Checking if we can move into that tile. We're gonna mark inside if not. So you're kind of doing a breadth first search as well. How do we ban a mod? Asking for a friend. Gee, you mix and match your X's and your Y's and your rows and your columns. So you loop through, you count all your steps if you can take that step, and then eventually you just end up dividing by 2. Nice solution for part 1. Nice simple solution for part 1. I love the naming here. Forbidden direction. Don't go that way. All right, part 2. You're gonna flood inside here. So we get the cell state. Mark inside stuff is for part 2. Okay. Part 2. For all of our points, if we're on the inside, we flood inside. I used a different less method ritual traveling the loop. I mark. Oh. So let me look at part 2 here. Because we have done part 1, you have ended up building the marking this if it's not visited. Very cool. Very cool. So you've marked it visited during part 1. So you do the traversal for part 2. It's necessary for part 2 in yours to do the traversal. So now we know of those points, we're going to flood inside. Oh, so you're already trying to find like the adjacent spaces inside, I believe. And then we do a flood points. How do you know the inside was right? Because of clockwise winding order. Yeah. So we know that like we're going around the edges here, the inside, because traveling is possible in both directions. And I decided whether inside is actually inside or outside. I do the based on the extra column. This is a really cool solution. Science, thank you for the pirates. Thank you for the pirate, folks. I'm gonna try not to get too distracted here. I really think this is a cool solution for doing the flood fill. So you say, find all the positions that I know for sure on the inside of my loop, that I know are for sure on the inside of my loop, and then do a flood fill on it. This is really cool. This is really cool solution. And then we count the enclosed. When there is an I in our additional detection column, we need to replace I and O and vice versa, inverting the cells. Incredibly cool solution here. Haven't you? I ain't seen no hacks yet. 9berry. A very cool solution. I really like this one. Today's puzzle is really cool. Points add. To make sure the direction you picked isn't incorrect before you rely on it. It's not a hack at all. Yeah. This is a really cool solution. I don't think I ever would have come up with this on my own. This is where it's so much fun to look at other people's solutions. Incredibly cool solution, 9berry. Thank you for sharing it. Nathaniel Bumpo. Nathaniel, thank you for sharing your solution. Let's take a look. We got a rust solution, so we're gonna make my brain sweat here. Let's pull this rust solution in. Like this. I thought of the expanded flood fill, the winding order plus flood fill, as well as the scanline approach. Still took me 3 hours to actually solve the test. Look, I was here for 4 hours this morning. Took me 4 hours. That, to be fair, if I'm being honest, I was doing a lot of chit-chatting here. I was dodging. Coding will dodging people talking at you. Not saying that I could have got it done quicker. Otherwise, but my brain's a little melty here. All right, whose solution are we looking at right here? Nathaniel. Points. Add Nathaniel 500 points. Thank you for sharing this with us. It's super fun though. Oh, before we do this, I want to give a shout out here. Cyan Streams reminded me of this cute little emote. You see this beautiful little emote down here? This is the Captain Pirate emote, folks. You guys may have noticed that Captain Coder I'm not an affiliate. I'm not an affiliate on Twitch. If you come to Captain Coder's Twitch, there's no points button. There's no points button here. What? Why? How do I subscribe? How do I get points? You can't, because I'm not an affiliate. I ain't no affiliate here, because I don't want any ads in here. We're gonna go into the void real quick. I don't want any ads here. But this means I don't get emotes, but my great friends here on Twitch have hosted my emotes for me. So check it out. We got all these beautiful emotes, that you can get by only subscribing to Captain Coder's favorite streamers, and then you too can get the Captain Coder collectible emotes and watch me woe into the void. You can watch me woe into the void. All right, folks. But yeah, these are my favorite. I want to give a shout out here. Give a shout out here to Irish John. Irish John Games. No. Irish John Games is one of my favorite streamers. He is a game developer here on Twitch. And he, let me close this out. He is working on a game here called Rise of Piracy. Be sure to give him some love. Click that link, wishlist it. We love Irish John here. Counting intersection points, a ray makes from any point. Yeah. But if you guys want to play a cool real-time strategy game based on pirates, multiplayer, single player, be sure to follow Irish John. He develops it here every day on Twitch. Incredible streamer. Someone said bold move to not go to avoid ads. Yeah, I just don't want any. I don't want you guys to. I hate ads. They drive me crazy. If I could be an affiliate without having ads, I would. But that's okay. That's okay. All right, here we're looking at Nathaniel's solution here in Rust. Viking N, is it Viking Gen 86 or Viking N86? I'm gonna go with Viking for now. Viking, oh Viking, thank you for following me. Oh, we've got Viking N86, thank you for following me today. Thank you, Viking. Let's take a look here at the solution. Thank you for the follow. But yeah, I don't need the money. I'm streaming for fun. The ads drive me crazy. I don't want anyone to have to watch ads here. And sometimes I teach things on this stream sometimes. Any way to access these solution links, let me post, this was posted in the chat here. I would love it. Here we go. This is Nathaniel's. This is what we're looking at right now. Let me do a pin. A pin. There we go. This is Nathaniel's solution. If you want to share yours, exclamation point Q to add it in. I only know Tactics 26. Welcome to the stream as well. Glad you're here on this beautiful day. But this is the one we're looking at here in Rust. Also, join on the Discord. We have some channels on the Discord where people share their solutions and we do a little bit of chit chat on them. I'd love to see more chit chat, but that's okay. It's okay. All right, we're gonna try and think through the Rust. We get an enum, down, left, up, and right. Direction, we can calculate our next direction based on RNC. Okay, so this is gonna give us, we have a thing here. If we go down, left, up, right, it just basically says the next direction from down is left, the next direction is up, next direction is right. Yeah, sales just we can post your links. Yes, G, thank you for that. If you send your link, it'll still send it here, G. So even if someone can't make it, it'll still make it to my questions log there. All right, so this is basically, we have a loop down goes to left, left goes to up goes to right, so that we can loop through all of them, I'm assuming. Next direction. Ooh, I like this. Ooh, I really like this. This is nice. It's saying that, oh, this is next position, not next direction. Sorry. Given a row and a column, if we're going down, we increase our row by 1. If we're going left, we decrease our column by 1. This is nice. Sorry, Nathaniel, thank you for the correction. Next direction, I really like this pattern match here. So much better than my solution. Because mine, I did a bunch of weird ifs. I kept wanting to have something like this. I really like this. You're saying if we're a bar and we're going down, then we keep going down. If we're a bar and we're going up, then we keep going up. Left, right. If we're going down into a pipe here, that's an L, we go right. I really like this declaration of flow. So calculating the flow through the pipe is really cool here. I really like this a lot. I'm jealous. Every time I see Rust code, it makes me jealous and makes me want to write in Rust. Because you guys got discriminated union types in Rust. Rust has discriminated unions, correct? If it doesn't have discriminated unions, what's the point? Does Rust have discriminated unions, Nathaniel? It does, yeah. I miss discriminated unions from back in my Haskellin. Every day it's Haskellin. I miss my generic algebraic data types, my GATs, my algebraic data types. Okay, so our maze here, we're gonna build up our maze here. We have our start and our grid. Our grid is essentially a two-dimensional array of characters, is what it looks like. And our start is a position, and then we have a direction that we're going. Smap, does C# have discriminated unions? Oh, there's a package. There are packages for it. Yeah, you can't pattern. You can't. Oh, cool. I'll have to look into that. Spoof. Thank you for being here. Hello. Happy Sunday. Hope you're having a beautiful day. And then we loop through all of our positions, and we build up our path. So we end up with our pipe loop here, and then our grid. A pipe loop. Java essentially got a lame version of discriminated, but it's limited, and you have to declare a sealed interface along every class that's ever been. I did some weird discriminated union types when I was building out a parser last year, and I was doing it with records, which was kind of interesting. It was like an interesting way to do it. Spoof says definitely harder than day 5. Spoof, thank you for the follow. Spoof, hang on. Spoof, thank you for following me on this day now. Spoof, thank you for the follow, friend. Spoof, thank you for following me today. Spoof, thank you for following me today. Spoof, thank you for the follow. Nathaniel, sorry to interrupt our regularly scheduled programming. But Spoof, thank you so much for the follow. Welcome aboard. Welcome to Captain Code Academy. We finished part 1, day 10, part 1 and 2. And so we're looking at solutions. So if you don't want spoilers, just a heads up, we're looking at solutions. We're looking at solutions here. But this solution here in our maze, when we build up the maze, we find the maze loop, and then we have our grid at the end, which is, I'm assuming, our original input. Correct me if I'm wrong, Nathaniel. All right. Determine start. I have something similar to this for determining the type of pipe that is in our start here. Let's look here. Generator here. We need that later. Yeah, I'm assuming so. Generator. Is this our parser? I'm assuming this is our parser, and then we construct a new maze with our grid, our start, and our start direction. This looks exactly like my solution for the parser, where I did a thing, and I was like, and then I have to figure out what the start is, and I set my start pipe. This is very familiar here to my solution in my parse. I find that kind of funny that my parse. I feel like my parse looks so much like yours, where I build up mine, and then at the end I say, all right, determine the starting shape, and then slap it in there. Yeah. Okay. Part 1. I wish I had done this. I feel like this is such a clever solution, but actually kind of obvious, where we have the length of our loop and we just divide by 2. I wish I had done that. That feels really smart. I did breadth first search. Or I guess I didn't quite do breadth first search. I did a flood fill on it. Gavadratisk says, can someone add a rule for the captain? No more singing under any circumstance. Your singing voice now has been identified as a weapon banned in the Geneva Convention. I've been murdering people with it a little bit. Spoof, use exclamation point Q to get it in there. Just exclamation point Q followed by your link should get it into the list. And we'll take a look. Thank you. All right. And then it keeps the order for me a little bit, so I appreciate it. All right, part 2. Let's see what we did here. Scan row by row, checking to see if we are in or out of the loop. So we've done something here. We can check if we're in or out of the loop. For each row in our line, we are looking at Rust right now. Box Akuva. box, we're looking at a Rust solution here. Isn't the flooring of length divided by 2 an issue? It's possible that I'm assuming the input is just lucky that it is in some ways constructed so that you can do this, so that's even. There is a little thing you'd have to do. Well, no, it has to be this. Otherwise, you'd have 2 positions that were equidistant from the start. It's impossible to navigate the discrete grid and end up back where you started in an odd number of steps. Yeah. Yeah, it's always divided by 2 because we know that there's exactly 1 position. We can't have a tied position. Can we? No, I'm not sure. I set myself the challenge to keep every part under 1 millisecond for as long as possible. I thought for sure I was going to fail today. You did it. Did you do it today, Spoof? 1 millisecond, a good one. No, it's impossible for you to navigate a discrete grid and end up. Gotcha. Okay. Looks like C# and C++ made a child. They did. It's called Rust. That's funny. Okay, so we're gonna go over every row and line. So is this the row, this is the index. This is the index, and this is the actual line. And then we're gonna be inside. So we have a thing that says whether or not we're inside or the outside. Inside or the outside. Same thing here. We have the index for the column we're on, and then the actual symbol. If our loop contains this row or column, row and column. So if our loop contains this, if we see a vertical, then we flip our state. A vertical is so these are things going up or down. We have to be consistent between J vertical, but either JL, X, or JF7 would work. We now know that we are on, we flip from being from the inside to the outside. So we're coming across, we're reading our input across. And if we hit a vertical, this is cool. If we hit a vertical bar, we know as we're coming across, we're either going to step inside or outside because we're going to cross our path. This is really cool. I really like this solution where we say we're coming across. If we see a vertical bar, that means that we had to have stepped over the vertical bar as we're going through. We stepped over the vertical bar as we were coming through. And we're essentially counting the number of times we've had to step over something, but we just have to toggle it on. So the first time we step over, I say, oh, now we're on the inside. Because we know it's a close loop, now we're on the inside. And then when we hit another one, we say, well, we're on the outside. So if we put 2 in a row, we're inside, we're outside, we're inside, we're outside. This is really cool. Otherwise, if we're on the inside, we count it. What a great solution. What a great solution to this. I really like this solution. And I'm really, yeah, what a great solution. Because my mind, I'm going like, wow, I gotta give a wow. This is a whoa. Whoa. This solution is awesome. Yeah. It would have so easy to just consider that for crossings, yeah. And then you could potentially do it from top to bottom as well, but then your crossings would be different. What a cool solution. I didn't even think about that. I just decided to do flood fill right out the gate. I was gonna I know if we could do a flood fill here, we'll be okay. This solution is magnificent. And so short. Look how tight this is. Look how tight this is. What a great solution, Nathaniel. Thank you for sharing it. How did I get the flood fill to work for part 2? Check it out. So we have this. I knew that we could do a flood fill, and my initial thought was, hey, can I do a flood fill in between? So I started explaining my thought process by expanding it out this way, and realized that if I just expand it out this way and fill in the blanks that are next to pipes, I can do a flood fill on this spoof. So if I go into my implementation, yeah, so I kind of accidentally stumbled into this this solution. I knew, yeah. So I expand the space, and if I do a .NET run here, you can see what the resulting expansion looks like. And then I can do a flood fill on the expanded version. I do a flood fill on the expanded version, and then I just count the leftover dots. So I do a flood fill that way. So I kind of recognize that part way through. Nathaniel, I love your solution. I love your solution. Let's take a look at Steve's solution next. Let's pull it in here. Steve is in C#. Steve is a hardcore, maybe I shouldn't say Steve's hardcore. Steve, your code is all, Steve is going for hyper efficient C# code though. Hyper efficient C# code. Or has in the past. So you'll notice these really cool things here where Steve is using some cool bit masking to make things tight, make things super tight in here. So directions, none, up, down, left, right, and all. We're using flags here, which is cool. Grumble of pugs, grumble of pugs, grumble, 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 grumble of pugs. Thank you for the raid, Grumble of Pugs. Welcome to the stream. Happy Sunday, my friend. How you doing, buddy? I hope you're doing well. Folks, if you guys aren't following Grumble of Pugs, incredible game development. Let's give a shout. Thank you for the shout out to Grumble of Pugs. Attention lurkers. Attention lurkers. If you guys don't know Grumble of Pugs, be sure to click that little heart right there. Give them some love. Give them some love. Grumble of Pugs, how was your stream? Feel free to drop any links you'd like here. But thank you for joining us. We're on Advent of Code Day 10. We finished part 1. We finished part 2. We're looking at solutions. I came up with a solution for part 1. I came up with a solution for part 2. We're looking at the cruise solutions now. So if you want to submit a solution, we take a look at it. Feel free to use !Q to submit it. We're looking at Steve's solution right now, which happens to be in C#. And Steve does some excellent, let's post a link to this here. Let's replace that. Let me get the link here to Steve's one more time. Steve's solution. We'll pin this up here. Is that gonna resubmit it? No, pin this message. There we go. All right, we're looking at Steve's solution right now. I work on this silly game. It's true. It's a silly game. It's a super fun silly game though. But we're taking a look. Dugong, thank you. Doug Ong, is it Dugong? Thank you for submitting your solution. We'll take a look at that when we get to it. We might run out of time today because these are so intricate and interesting. But yeah, we've built up this bit mask here, which is really cool way to do it. Dugong, thank you, Dugong. Welcome to the stream. Happy to have you here. But folks, be sure to give real quick before we do this. I just gotta tell people. I gotta implore you, encourage you. Go check out Megabat. Download the demo and be sure to add it to your wish list. It really helps things out if you add it to your wish list. There's if it looks interesting to you. But look at this beautiful pixel art. This game looks amazing. Thank you for being here, Grumble of Pugs. Okay, so we build up this thing here. It's really cool. You're storing it as a byte, which is even better. I know I gotta go in 10 minutes. We're gonna go a little bit long. But I'm just having so much fun here doing it. Folks, we might have to wrap up after this one, actually. Thank you, G. I don't want to go. The captain just loves you guys so much. Have a beautiful day on your Christmas run, Grumble Pugs. Keep coding, keep growing, be the best you can be, and you're welcome back anytime. 4 bits of unused space in that byte. Steve, you're wasting bits. You're wasting bits. Come on, they're just wasting away. Kvadritisk. Hilarious. All right. Directions enumerator. Only 3. Only 3. That's okay. It's okay. You know how many bits I'm wasting? So many bits in mine that are being wasted here. Okay. Directions. Given our direction of our bits, we pull it in, and then... Oh, no, this is a struct. Current direction, move next. We can do some bit manipulation and masking to find out the next direction. Cute solution here. Our array of directions. Ooh, left down. Because you've done your directions in this clever way, we can do some really cool bit masking here to say, or basically a combination of these enums, this cool bit masking to get our different directions this way. You've done something here, and I'm assuming this is to make it easy to do in the lookup array here. You're gonna give it an index, and you're gonna pull these things out here. Love me a bit flag. It's pretty cool. All right. From char, yeah, this is exactly what I was saying. Directions lookup. We can take in a character, and then using that character, we're able to get the directions that we can move. The aggressive inlining, yeah, spoof. Gotta get that fast. Just inline here. It says don't use this as a method. Just put it in. Yeah. Okay. So from char. I almost said from chair. From char. Get complement here. So this is going to be the directions that are going the opposite. Can connect to here is so saying if we're going up and down, we're going to get this spot above and below. If we're going left and right, we're going to get left and right. If we're going up and then to the right, it's below and to the right. So really clever way you set these things up in a very clever way to be able to do all this. Makes the code impossible to read. Not really, but in my mind, hard to read. But I love going for the hyper efficient is super fun to do. I'm loving this. I'm loving it. We're going to get a delta. So int vector 2D, I don't know quite what this is doing, but we're going to get a delta. Given a direction, we get the delta. And the delta is the new X and Y. Sometimes it's just more fun to avoid a branch with unreadable code. So it was doing this. Given our up, down, left, or right, we're gonna get the direction we want to go with it. Okay, and we get our directions enumerator, which given a directions just gonna give us back the new DIRs. Directions, new. Is this thing an enumerator? There it is. Okay. Turn it in there. It's just a vector struct I wrote. You could more or less replace it with a pair, but you gotta get that efficiency. All right, here we go. It's really cute, clever, horrifically fun to look at. How's the box? How sick is this code? If by sick you mean amazing. If you want to get down, you're getting all the nitty gritty bits and bytes. Getting in there, making it as efficient as possible. Yeah. All right. So now we have our base. We have our width, our height, our path length. We have our start, and then we have. This is essentially, I think, going to give us in our grid the directions we need to go. You'd be surprised how efficient you can get in C# box. It's amazing, right? That's what I'm saying. It's one of the things I actually really love about C# is they give you the ability to really get in there into the nitty gritty details and play around with the bits and bytes as close as possible. If you don't stress the garbage collector, yeah, which is sort of what we're doing. This is amazing. Read the data in here. We find our S. We're going to build this thing up. We're going to enumerate through all these. Our start here. We're building up our grid. Creating a span. We're going to create a span for our grid. We know how much space we need, and we're going to build up our from direction. Read all the data and vectorize it. Grid span. Go through our ID X. So we start at -1, and then we are 0 here. So we're building up our grid here, and you have it in a. Looking up, you probably do a multiplication to find the row column or something in here. Let's look. Traverse and mark visited. We get our first node after the start because our start here is going to take a step in a direction. Just avoids multiply and add. Yeah, that's what I was saying in the 2D vector. It's kind of cool what you've done here. And then as long as we are not at the start, we keep traversing. So you're building out the loop here. So we say start, go to our start, and then we're gonna iterate down, taking a step, building up our length, marking things as visited, building up our grid array here. And then we return that length here. And for part one, I'm assuming, where's your part one? Part one, you just take the path length divided by 2. This is a thing that I wish I had realized. Everyone's doing this but me, and I really like that. So we go through and we traverse it, and then we divide by 2. Okay, so now get first node after, count interior points. I believe this is gonna do the same thing. Correct me if I'm wrong. This is doing the same thing where when we step over, we sort of are saying either we're in or we're out. You're calculating the in or out. Is that true, Steve? Let me know, because I don't, like, my brain is mushy here a little bit. Structs and primitives land on the sec. For the most part, that's true. Arrays end up on the heap. Arrays will be on the heap because they're considered objects. Someone correct Steve. Are spans on the stack? Spans are on the stack. G saying you gotta get out of here. There or primitives, yeah. So doing it as a span, it will be on the stack. Is that true? Okay. So we've done this thing here, this really clever thing where we're looping over all and we're saying, are we stepping over? Which I think is such a cool solution because we know it's a closed loop. If you step over it, you know that you're going into. So it's not possible to copy them onto the heap at all. Gotcha. Yeah, beautiful, beautiful. Oh, it won't even allow you to put in only a view into the array. The array is still on the heap, I think. I'm curious, Steve. Someone let me know if that's true or not. I think that's an interesting. But members land on the heap as well. No, right. The array is on the heap, and the span has a pointer and a length. Gotcha. You can put an array on the. You can put an array on the stack alloc. Array. You could do this. Stack alloc new int 5. You can put arrays on the stack like this, though. Yes. Yes. Okay. Then we count the interior points. So we do the same solution we saw before, where when we have a bar that's going vertical, we say we step over. We step over the direction. The code is too amazing to understand. I don't think it's actually that complex to understand. We just have a lot of cool tricks that we have to understand. So that's why I'm saying I'm pretty sure we're just checking whether or not we're on the inside or the outside with the vertical parity. So no allocation. Steve's done this with like no allocation. It's really cool. Kind of sad that I went to just the pure math solution. That's okay. All right, folks, I'm so sorry. I hate that I have to go here. We're gonna give some points here. Points. I'm not gonna be able to look at all of these solutions. 13,500 points. Add here. Join the leaderboard is first. Alco, welcome to the leaderboard. All right, folks. What I'm gonna tell you to do though, if you'd love to, I would love to see more of these solutions. Please, if you'd like to share your solution, join the Discord. Join the Discord. And then under the day 10, post your solutions. Post your solutions here on the Discord. We'd love to check them out, take a chat at them. And I'm so sorry, Zorik. I'm just out of time here. We'll be back tomorrow, though. I'm so sorry. We got to give Zorik points. Points, add, Scally Game Dev, 500. points. Add. Let's get everyone points in here. Add Alka. I'm so sorry that we don't get a look at everyone's solution. I'm bummed out of it. I got to get out of here though. Lanky telephone. But please, if you would, share them on the Discord. We can take a look at them. Oh, it won't let me do that one. I'll try that again in a second. G, thank you for sharing your solution. I'm so sorry, folks. I've been going for 5 hours. We'll be back tomorrow. Day 11. Let's see if I can get Lanky telephone here. 500. It's one of those weird names that won't let me add people. Spoof, yours is here. Spoof, did I miss you? Sorry, Spoof. I'm just rushing. Add Spoof, 500. Thank you guys so much for being here. We'll be back tomorrow. For more Advent Code, day 11. Hopefully we'll get it in there, get it done. Love having you guys here, for making it all the way to the end of the stream. All you wonderful people, 250 points. You're still up from last night. Yeah, I got up at 5 this morning. You're welcome. Thank you guys for being here. We got to find someone to raid out too. Let's see. Who do we got? Twitch. Who do we got? Who do we want to raid? Is it okay to get nervous in an interview? How to stay calm? Like, I mess with one of my interviews. It's okay to get nervous. I think it's absolutely normal to get nervous in an interview. I think the best thing to do is the best thing to do to not be nervous is to stay calm. What a dumb thing of me to say. Working on staying calm is practice your interviews. Not always, but I try to tell people, let's look for Advent of Code. I think it's okay to get nervous in an interview. I think that's very normal. I think one of the best things, breathing exercises can be super helpful. Breathing exercises can be super helpful for helping you to relax. And then also practicing interview questions, practicing interviewing, get someone to ask you lots of questions. Just to practice it. But normally nervous is just normal. Yeah. So I think that's normal. And breathing is a good one. Learning how to breathe well. All right. Richard or Charles is doing Advent of Code in C#, it looks like. So I think that's where we're going to go. Let's take a look. Richard or Charles. They're doing the poker problem, it looks like. The poker problem. So we might go there. Let's take a look. Who else do we got? Here are our choices for people who are doing Advent of Code. Any Crayon Crayoff, Virtual Harby. The poker one I really enjoyed. All right, folks, we are gonna go raid, I think. What is Crayon Crayoff doing? Attempting and failing. Let's see which puzzle we're on here. Day 6. They're on day 6. All right. Yeah. We're gonna go raid Richard or Charles, folks. Richard or Charles. Crayoff's going an hour and a half. Richard or Charles has been going for 2.5 hours. We're gonna go raid Richard or Charles, everybody. So hang tight, folks. Give them some love when we get there. This is my first time checking out Richard or Charles, but give them some love. We're going to give a raid here to Richard or Charles. Tell them the captain sent you. Get your raid here. Captain, keep coding. This is going to be our raid message. This is the first time I've ever said, here's a raid message, folks. Here's our raid message. Keep coding. I don't know what else to say. I'm bad at this game. All right, folks, I got to get out of here. Remember to keep coding, keep growing, be the best you can be, and you're welcome back anytime. We'll be back tomorrow. I'll see you then. Bye-bye.